Imagine stepping outside on a clear night, far from the glow of streetlights and screens, and gazing upward into a sea of stars, so vivid it feels like you could reach out and touch them. This is the sky our ancestors knew intimately, a vast, living canvas where every glimmering point of light held meaning, mystery, and memory. They didn't just see scattered specks of brightness, they saw stories written in the constellations, divine messages whispered from the cosmos, and celestial maps that guided their lives, their journeys, and their very understanding of existence. For thousands of years, human beings across the globe have looked up with a sense of cosmic loyalty, binding themselves to the rhythms and revelations of the night sky in ways that shaped civilizations, inspired religions, and forged cultural identities that endure to this day. In this video, we're setting out on an extraordinary journey to explore how ancient cultures interpreted the heavens, not as distant, cold objects of scientific study, but as intimate, powerful forces intertwined with daily life. We'll travel from the deserts of Egypt to the islands of Polynesia, from the stone circles of Europe to the ceremonial centers of the Americas, uncovering the rich tapestry of myth, astronomy, and spirituality that connected humanity to the stars. You'll discover how the Babylonians used planetary movements to predict the fate of empires, how the Maya aligned their pyramids with the solstices to honor the cycles of time, and how indigenous navigators crossed entire oceans using nothing but the stars as their guide. These were not primitive beliefs but profound, sophisticated systems of knowledge that blended careful observation with deep reverence. What's truly remarkable is how these ancient interpretations still resonate with us, often in ways we might not even realize. The stories our ancestors told about the heavens live on in our art, our language, and even our modern fascination with astrology and space exploration. By understanding their cosmic loyalties, we not only gain insight into the past but also rediscover a sense of wonder and connection that can feel all too rare in our fast-paced, technology-driven world. So join us as we dive into this captivating exploration of the night sky through the eyes of those who first found meaning in its depths. You might just find that looking up at the stars will never feel the same again, and that you too are part of this timeless celestial story. Picture yourself standing on the open plains tens of thousands of years ago, with no electric lights to dim the overwhelming darkness, only the moon and a breathtaking tapestry of stars illuminating the world around you. For our earliest ancestors, this was not a rare spectacle but a nightly reality, a vast, dynamic canvas that demanded attention and interpretation. Without the written word or sophisticated tools, they relied on acute observation and memory, passing down celestial knowledge through stories, songs, and art. They began to recognize that the heavens were not static, they moved in reliable, repeating patterns. The same group of stars would appear in the east just before the spring rains began, signaling the time to plant crops. Another constellation would climb to its highest point as the days grew shorter, a warning to gather stores for the winter. This was humanity's first foray into science, a meticulous, generations-long project of mapping the sky's rhythms onto the needs of survival. But this relationship with the cosmos was far more than a simple exercise in practicality. It was deeply woven with spirituality and a sense of awe. Imagine the profound mystery of a lunar eclipse, the slow, silent disappearance of the moon, a constant companion into shadow. Or the sudden, terrifying appearance of a comet, a stranger with a fiery tail streaking across the familiar patterns. These events were not seen as random natural phenomena, but as powerful communications from the divine. The sky was a realm of gods and spirits, and its movements held direct sway over human fate. This belief is etched into some of humanity's oldest art. In the famous Lascaux cave paintings in France, dating back over 17,000 years, among the depictions of bulls and horses, scholars have identified what may be a representation of the Pleiades star cluster, and even a large aurochs painted where a bull might be in a constellation. This suggests that even in the Paleolithic era, humans were not just looking at the stars, they were integrating them into their mythologies and their very understanding of existence. This fusion of the practical and the spiritual created a unique form of cosmic loyalty, a reliance on and reverence for the heavens that guided every aspect of life. For nomadic tribes, the stars were a literal roadmap. The changing positions of certain asterisms could indicate the direction of migratory animal herds or the safest paths to travel. For early agricultural societies, the stars became a celestial calendar far more reliable than any early human-made timekeeping device. The heliacal rising of a particular star, its first appearance in the dawn sky after a period of invisibility, could announce the flooding of a river vital for irrigation, like the Nile in Egypt, or the arrival of the monsoon seasons. This knowledge was so critical to community survival that it became sacred, entrusted to shamans, elders, and storytellers who could read the celestial signs. In this way, the night sky served as humanity's first clock, its first calendar, its first navigational system, and its first temple, all rolled into one. It was a universal library written in light, and every culture on Earth learned to read its pages, setting the foundation for every astronomical discovery that was to come. Out of the silent, swirling patterns of light, our ancestors wove some of humanity's most enduring stories. The constellations were far more than simple connect-the-dots pictures. They were a grand, celestial storybook, with each culture writing its own epic chapters across the dome of the night. For the ancient Greeks, the familiar shape of Orion was not just a hunter but a giant of immense pride, placed in the sky by the gods as a warning against arrogance, forever chasing the seven sisters of the Pleiades across the firmament but never able to catch them. This tale wasn't merely entertainment. It served as a moral compass, teaching lessons about hubris and the consequences of one's actions. Similarly, the Egyptians didn't just see the star Sirius, they saw Sopdet, the goddess Isis in her celestial form, whose first appearance just before dawn each year heralded the life-giving inundation of the Nile River. This event was so critical to their survival that their entire calendar was built around it, marking the new year and dictating the agricultural cycle. The star's return was a time of immense celebration and religious significance, directly linking the divine to the daily lives of every person along the river. This process of myth-making was a universal human impulse, a way to transform a cold, indifferent universe into a familiar and meaningful landscape. By giving names, personalities, and motivations to the stars and planets, our ancestors created a cosmos that was populated with characters they could understand, appeal to, and even fear. The unpredictable wrath of a storm could be explained by the anger of Zeus throwing lightning bolts. The gentle, predictable return of spring might be attributed to the goddess Persephone returning from the underworld. This personification made the vastness of space manageable, providing a framework to explain the otherwise terrifying and inexplicable events of the natural world. It answered fundamental human questions about why the sun rises, why seasons change, and what causes an eclipse, filling the unknown with narrative instead of uncertainty. These celestial stories also functioned as the glue that held cultures together, reinforcing a shared identity and common values. The Babylonians looked at the planet Venus and saw Ishtar, the powerful goddess of both love and war, reflecting their understanding of the dual nature of power and passion. In the far north, the Inuit people saw the constellation we know as Ursa Major not as a great bear but as a giant caribou, an animal central to their survival and culture. By projecting their most important symbols, animals, and deities onto the stars, communities created a shared celestial heritage. Gazing up at the same stories night after night reinforced a collective worldview, reminding everyone of their place within the tribe, their history, and their responsibilities to each other and to the gods. This shared sky became a common text, a cultural touchstone that could be referenced in poetry, invoked in ritual, and used to teach children the values and history of their people, ensuring that the wisdom of one generation was passed quite literally to the next. This deep, inseparable link between the heavens and human authority created a powerful form of cosmic loyalty that shaped entire civilizations. In ancient China, the concept of the mandate of heaven was not just a political idea, it was a cosmological one. The emperor, known as the Son of Heaven, derived his right to rule directly from the celestial order. Astronomers were high-ranking court officials whose primary duty was to meticulously observe the sky for any sign of divine displeasure. An unexpected comet, a sudden eclipse, or the erratic movement of a planet was not merely a scientific curiosity, it was a direct commentary on the emperor's virtue. If such an omen coincided with natural disasters or social unrest, it could be interpreted as heaven withdrawing its mandate, potentially justifying rebellion and the rise of a new dynasty. The sky was a moral barometer, and loyalty to the emperor was fundamentally loyalty to the cosmic harmony he was chosen to maintain. This pattern of celestial validation was echoed across the globe. Half a world away, the Maya lords of Mesoamerica were also masters of astronomical propaganda. They built towering pyramids like the one at Chichen Itza, which was precisely engineered so that during the equinoxes, the interplay of sunlight and shadow would create the illusion of a serpent slithering down the staircase. This was no mere architectural marvel, it was a breathtaking piece of political theater. The ruler, positioned at the summit, became the living conduit between the people and the gods, his power visibly manifested through this controlled celestial event. His ability to predict such moments, to seemingly command the sun and the stars proved his divine right to lead and demanded absolute loyalty from his subjects. Their calendar, one of the most accurate ever created, wasn't just for tracking time. It was a sacred schedule that dictated when to wage war, when to crown a new king, and when to perform rituals to ensure the sun would continue its journey. To follow the calendar was to participate in the cosmic order itself. Beyond the palaces and pyramids, this cosmic loyalty seeped into the very fabric of daily life, uniting communities under a shared symbolic sky. For many cultures, the constellations overhead were not abstract pictures but reflections of their most vital cultural symbols. The 7 stars of the Pleiades cluster, for instance, were seen by the Aboriginal peoples of Australia as a group of sisters being chased by the hunter Orion, a story that dictated law and social behavior. For the Native American Lakota, the same stars represented a sacred council of leaders. In each case, the stars reinforced a collective identity, reminding people of their shared stories, laws, and ancestry every single night. This shared celestial heritage fostered a powerful sense of belonging, a loyalty to the tribe and its customs that was written in the immutable lights above. This profound connection even dictated the practicalities of survival and construction. Agricultural cycles were intrinsically tied to the stars' movements. The pre-dawn rising of Sirius told Egyptian farmers to prepare for the Nile's flood. while the appearance of the constellation Scorpio in the sky might signal to another culture the time to begin the harvest. Architecture, too, was often a physical echo of the cosmos. The layout of ancient cities, from the Forbidden City in Beijing to the ceremonial centers of the American Southwest, was frequently aligned with cardinal directions based on stellar observations, turning entire settlements into terrestrial models of the celestial order. This wasn't just city planning, it was a way of grounding cosmic principles into the Earth, ensuring that human society existed in perfect harmony with the universe. By examining how the same stars were given completely different meanings, how one culture saw a bear where another saw a wagon, or a dragon where another saw a river, we see a spectacular tapestry of human imagination. It reveals our universal need to look up, find patterns, and weave those patterns into the story of who we are, creating a sense of purpose and belonging that stretches from our ancestors around the communal fire to us today, still gazing up at the very same stars. Without telescopes or satellites, ancient astronomers relied on something even more profound: monumental architecture and mental maps of breathtaking precision. Consider the great stone circles like Stonehenge on the Salisbury Plain. For centuries, its purpose was a mystery, but we now understand it as a sophisticated astronomical computer built of stone. The massive heel stone, positioned outside the main circle, aligns perfectly with the rising sun on the summer solstice, casting a beam of light deep into the heart of the monument. Other alignments track the movements of the moon and mark eclipses. This wasn't just a calendar. It was a sacred space where the community could gather to witness the reaffirmation of cosmic order, their agricultural lives and spiritual rituals perfectly synchronized with the sky cycles. The effort to transport and erect these multi-ton stones speaks to the immense importance they placed on this celestial connection. This fusion of temple and observatory reached its zenith in ancient Egypt. The Great Pyramid of Giza is a masterpiece of celestial engineering. Its sides are aligned with almost uncanny accuracy to the four cardinal directions north, south, east, and west, with an error margin of less than 1/15 of a degree. How did they achieve such precision without modern tools? They likely used the stars themselves, perhaps tracking the circular motion of a single star around the celestial pole to find true north. Even more astonishing, the narrow shafts extending from the king's chamber were once thought to be ventilation shafts, but Egyptologists now believe they were precisely angled to point directly towards specific stars sacred to the Egyptians, like Sirius and Orion's belt. These stars were associated with Osiris and Isis, gods of the afterlife, suggesting the pyramid was designed as a machine to literally funnel the soul of the pharaoh directly into the heavens to join the eternal gods. The building was both a tomb and a launchpad for immortality, a physical manifestation of their belief that earth and sky were two parts of a single, continuous realm. While some cultures built in stone, others crafted intricate portable devices. The Babylonians, master mathematicians of the ancient world, used an early form of the astrolabe known as a star finder. This was a complex system of calculated tables and simple instruments that allowed them to predict planetary positions, lunar phases, and the timing of events we would now call sunrises and sunsets. Their meticulous, century-long records of celestial events, inscribed on clay tablets, revealed repeating cycles that formed the basis of their divination practices. For them, predicting an eclipse was not just a scientific achievement. It was a way to anticipate the whims of the gods and advise their kings accordingly, preventing potential calamity. This blend of precise math and spiritual belief shows that for them, science and religion were not separate fields but two sides of the same coin, both essential for understanding and navigating a world governed by celestial forces. Perhaps the most elegant and portable tool of all was the human mind, trained to an extraordinary degree. The Polynesian voyagers who settled the vast Pacific Ocean possessed no stone monuments or metal instruments. Their entire navigational system was based on knowledge memorized through song, story, and rigorous apprenticeship. They were living observatories. They knew the precise rising and setting points of hundreds of stars, using them as a compass across the open ocean. But their knowledge went far beyond just the stars. They learned to read subtle patterns in ocean swells, feeling the way their canoe was pushed by currents that reflected the presence of distant islands. They watched the flight paths of birds at dusk, knowing certain species would fly toward land to roost. They observed the interplay of light and clouds, which often gathered over the lush vegetation of an atoll long before it was visible to the eye. This holistic environmental astronomy allowed them to traverse thousands of miles of open water with confidence, their loyalty to ancestral knowledge and the guiding stars enabling one of the most incredible feats of exploration in human history. Each of these tools, from the megalithic to the mental, reveals a universal truth about our ancestors. They saw no divide between the sacred and the scientific. To understand the cosmos was to participate in its divine order, and every innovation, whether a pyramid or a song, was a step toward that ultimate harmony. While the great stone circles and pyramids stand as silent monuments to ancient astronomy, this celestial knowledge was not held by everyone. It was the domain of a select, powerful few, the priests, the shamans, the seers. These individuals were the original data scientists and spiritual guides, the keepers of the sky's secrets. They spent years, often lifetimes, memorizing the intricate dance of the heavens, learning to predict the return of a planet or the ominous approach of an eclipse. This wasn't just academic study, it was a sacred calling. They were the vital bridge between the human community and the vast, often intimidating cosmos. Their unique ability to interpret divine messages written in the stars granted them immense authority, making them indispensable advisors to kings and central figures in the spiritual life of their people. This specialized knowledge created a distinct hierarchy, a system of cosmic loyalty where understanding the heavens directly translated to power on Earth. A ruler's legitimacy often depended on the blessing of these celestial interpreters. In ancient Mesopotamia, for example, the king was never alone in making a momentous decision, whether to go to war or to enact a new law. He would first consult his team of priest astrologers known as the letter 1, D5 3 letter 1 E6 DIPPU. These scholars would meticulously examine the liver of a sacrificed sheep for marks they believed were influenced by the planets, and they would scour the night sky for any sign from the gods, a comet, a meteor, an unusual alignment. Their interpretation could delay a coronation for months or send an army marching in a different direction. The will of the gods, as read in the stars, was the ultimate authority, and the priests were the only ones who could translate it. This dynamic played out with breathtaking sophistication in the Maya civilization of Mesoamerica. The Maya day keepers, or letter 1 D5 3 Ajkajab, were masters of time itself. They maintained and interpreted several interlocking calendars of staggering complexity, including the sacred 260-day Tzolk'in and the solar-based Hab. By tracking the movements of Venus, which they associated with war, and predicting solar eclipses, which they viewed as a moment of potential cosmic imbalance, they could advise their kings on the most auspicious dates for everything from planting crops to launching military campaigns. A king who ignored this celestial counsel risked not only failure but also the displeasure of the gods. The shaman's ability to seemingly control time and predict cosmic events reinforced a social order where spiritual and political power were two sides of the same coin. both validated by the unchanging cycles of the sky. A similar, deeply integrated system flourished in ancient India with the Vedic astrologers, or Jyotishis. For them, the moment of a person's birth was not random. It was a unique snapshot of the cosmos, a celestial fingerprint. They would chart the precise positions of the planets against the backdrop of the fixed stars at that exact instant, creating a detailed birth chart, or Janma Kundali. This chart was believed to map out one's destiny, personality, and life path. It was consulted for all of life's major events: marriage, business ventures, even naming a child. The Jyotishi's role was to decipher this cosmic blueprint, to identify periods of opportunity warned of by challenging planetary transits, and to prescribe rituals or remedies to align an individual's life with the harmonious flow of the universe. In this system, cosmic loyalty was deeply personal, governing the fate of every individual from cradle to grave under the watchful eyes of the priest-astrologer. This concentration of knowledge, however, also had a profound social consequence. It created a powerful intellectual elite, a class of individuals who alone could speak the language of the gods. This access gave them tremendous influence, but it also meant that this critical understanding of the natural world was often shrouded in mystery and ritual, accessible only to those initiated into its secrets. The average farmer knew to plant when the priest said the star was right, but he did not necessarily know how to read that sign himself. This established a system where faith in the interpreter was just as important as faith in the cosmos, binding the community together through a shared reliance on a specialized few who could navigate the celestial currents and ensure that human life remained in sync with the divine order. Long before the Greeks named the planets or the Romans built their empires, the Fertile Crescent between the Tigris and Euphrates rivers was the birthplace of systematic astronomy. Here, in the dust and heat of ancient Mesopotamia, the Sumerians and later the Babylonians looked up and saw not just stories, but a complex, divine bureaucracy at work. They were the first great archivists of the sky, and their legacy, etched into thousands of clay tablets, reveals a civilization that believed every shimmer of light was a memo from the gods, a piece of celestial legislation that demanded a human response. Their entire worldview was built on a fundamental principle: as above, so below. The orderly movements of the heavens were a direct reflection of the proper order on Earth, and any disruption in the sky, a comet, an eclipse, a planet behaving strangely, was a dire warning of disruption to come in the king's court or the harvest fields. This wasn't idle stargazing. It was a state-sponsored science with immense practical and political weight. Scribes, who are also priests and scholars, stood on the flat rooftops of ziggurats night after night, meticulously recording the position and brightness of planets against the fixed backdrop of stars. They didn't just note that Jupiter was bright, they recorded its precise path, its retrograde motions, and its conjunctions with other celestial bodies. Each planet was the physical embodiment of a powerful deity. The blood-red disk of Mars was Nergal, the god of war and pestilence. The steady, brilliant light of Jupiter was Marduk, the patron god of Babylon and the head of the pantheon. And the shimmering, beautiful Venus was Ishtar, the captivating and volatile goddess of both love and fierce war. A planet's movement wasn't just orbital mechanics. It was the literal movement of that god through the divine realm, and its actions were meticulously interpreted. If Mars approached the constellation representing an enemy land, it might mean Nergal was blessing a military campaign against them. If Venus disappeared into the sun's glare and then reappeared, it signaled Ishtar's return from the underworld, a time of potential renewal or upheaval. Their most enduring contribution, one that still shapes millions of lives today, was the creation of the Zodiac. In their effort to track the sun's path, they divided the band of sky it travels through into 12 equal sections of 30 degrees each section named after the constellation that resided there. This ecliptic path became a celestial highway, and the movement of the sun, moon, and planets along it could be plotted with incredible precision. This system gave them a powerful predictive tool. They could forecast lunar eclipses with remarkable accuracy and understand the cyclical nature of planetary movements. But for the Mesopotamians, prediction was never just about math, it was about divination. This practice, known as astral omen astrology, was detailed in vast encyclopedic works like the Enuma Anu Enlil, a 70-tablet series that served as a manual for celestial interpreters. An omen might read, "If Venus rises in the east in the month of Adaru, there will be devastation in the west." The court astrologer's job was to read these signs and advise the king on how to avert disaster, perhaps through a specific ritual, a change in policy, or even by installing a substitute king to bear the brunt of the predicted divine wrath. This meticulous, data-driven approach, fueled by a deep-seated belief in a communicative cosmos, established a template that would ripple out across the ancient world. The Mesopotamian legacy is not just in the stars they named or the zodiac they invented, but in the very idea that the universe operates on knowable laws, that careful observation can reveal patterns, and that those patterns have a profound meaning for our lives here on Earth. They laid the groundwork not only for astrology but for all of Western astronomy, creating a system where the pursuit of knowledge about the heavens was, from its very beginning, a sacred act of listening to the gods. While the Mesopotamians were developing their system of celestial omens, along the Nile River another civilization was forging an even more intimate bond between the earth and the sky, one where the boundary between the divine and the daily was almost non-existent. For the ancient Egyptians, the cosmos was not a distant realm of gods sending messages. It was a perfect mirrored reflection of their own world, a divine blueprint made manifest in light. The vast, shimmering band of the Milky Way arching overhead was not an abstract collection of stars, it was the celestial Nile, the life-giving river of the heavens, flowing through the dark field of night just as the earthly Nile flowed through the fertile black soil of Kemet, the Black Land. This was a universe of profound symmetry where every earthly feature had its counterpart in the sky, and the gods themselves walked among the stars. This celestial mirror was populated by deities who are also constellations. The most important of these was the star Sirius, known to the Egyptians as Sopdet, which we recognize today as the goddess Isis in her heavenly form. For most of the year, Sirius was absent from the night sky, lost in the glare of the sun. But each year, after a 70-day period of invisibility, it would reappear just before dawn in the eastern sky, an event known as its heliacal rising. This momentous occurrence, happening around mid-July, coincided almost exactly with the beginning of the annual Nile inundation, the flood that would deposit rich, new silt across the farmlands, ensuring another year of abundance and life. The return of Sopdet was the return of Isis, heralding the rebirth of the land and the promise of renewal. It was so critically important that it marked the start of their new year and was the foundation of their solar calendar, a system of timekeeping so accurate it was only off by one day every 1,460 years. The entire rhythm of Egyptian life, from farming to taxation, was set to this celestial clock, making cosmic loyalty a matter of literal survival. The story of Isis and Osiris is perhaps the most poignant example of this sky-earth connection. Osiris, the god of the afterlife and rebirth, was murdered and dismembered by his brother Set. His devoted wife, Isis, tirelessly gathered his parts and used her magic to resurrect him just long enough to conceive their son, Horus. Upon his final death, Osiris was transformed and ascended to the heavens, becoming the constellation we know as Orion. Isis, as the star Sirius, follows him eternally across the night sky, their celestial dance mirroring their mythical love and loss. Their son, Horus, often associated with the sun god Ra, was represented by the living pharaoh on earth. This meant the pharaoh was the divine heir, the human embodiment of Horus, ruling under the watchful eyes of his starry parents. This mythology wasn't just a story, it was a cosmological framework that explained the cycle of death and rebirth, the passing of royal power, and the very promise of an afterlife. This belief in a stellar afterlife was central to Egyptian religion and explains the incredible precision of their most famous structures. When a pharaoh died, he was not gone, he was transformed. His soul would undertake a perilous journey to join Osiris in the constellation Orion, becoming an undying star, an axe spirit, in the eternal circuit of the heavens. The pyramids were not merely tombs, they were immense resurrection machines and celestial launching pads designed to facilitate this ascension. The Great Pyramid of Giza's air shafts, once thought to be for ventilation, are now understood to have been meticulously aligned. The southern shaft from the king's chamber pointed directly to the belt of Orion, the location of Osiris, at the time of its construction around 2500 BCE. The northern shaft targeted Theban, the North Star of that era, the seemingly fixed, unchanging pivot around which the entire cosmos turned. Every aspect of its construction, from its perfect cardinal alignment to the internal chambers, was an act of sacred engineering meant to guide the soul of the divine king on its final, most important journey from the earthly realm to the eternal stars. This deep, seamless integration of astronomy into every facet of existence, mythology, agriculture, timekeeping, architecture, and the divine right of kings, created a society uniquely harmonized with the universe. Their cosmic loyalty was a faithfulness to Maat, the fundamental principle of truth, balance, and cosmic order. To live in accordance with Maat was to align one's actions with the predictable movements of the stars and the reliable flooding of the Nile. It was a worldview of beautiful, reassuring cycles where death was always followed by rebirth, and the human soul had a guaranteed place in the glittering fabric of the night sky. The enduring precision of their monuments stands as a timeless testament to this belief, a stone and mortar prayer to the heavens that continues to inspire awe and wonder millennia after the last pharaoh took his place among the stars. Across the ocean, in the dense rainforests and highlands of Mesoamerica, a radically different cosmic vision flourished, one where the sky was not a separate divine realm but a living, breathing layer of a multilayered universe, intimately woven into the very fabric of human existence. For the Maya, the Aztec, and the Inca, the cosmos was a single, interconnected organism. The Earth was not a planet floating in space but the middle world, suspended between the 9 layers of the underworld, Xibalba, and the 13 layers of the upper world, the domain of the gods and celestial bodies. A great world tree, often represented by the majestic ceiba tree, pierced through the center of this cosmic stack, its roots delving deep into the darkness below and its branches reaching up to hold the stars. This was not a metaphor, it was a geographical and spiritual reality. Gods, ancestors, and celestial forces moved freely between these layers, and humanity's role was to maintain the delicate balance between them through ritual, sacrifice, and precise astronomical observation. No civilization embodied this pursuit of balance more than the Maya, who became the master timekeepers of the ancient world. Their understanding of celestial mechanics was nothing short of breathtaking. They tracked the synodic period of Venus, the 584 days it takes for the planet to return to the same position relative to the Sun, with an error of just 1 day in 500 years. But this wasn't done for abstract scientific curiosity. Venus, known as No-Ek or the Great Star, was associated with the god Kukulkan, whom the Aztecs would later call Quetzalcoatl. Its movements were deeply feared. When Venus rose as the morning star after a period of invisibility, it was seen as a time of war and bad fortune. Maya rulers would often schedule raids and military campaigns to coincide with its first appearance, believing the god's baleful influence would grant them victory. They could also predict solar eclipses with remarkable accuracy, events they viewed as a moment of profound danger when the sun was being bitten by a demon, threatening to plunge the world into permanent darkness unless the gods were appeased with offerings. This sacred astronomy was literally set in stone. The Maya built their cities as terrestrial models of the cosmos. The pyramid at Chichen Itza, known as El Castillo, is a stunningly precise architectural calendar. Its 4 sides each have 91 steps, which, added to the single step of the temple platform at the top, equals 365, one for each day of the solar year. But its most famous feature occurs during the spring and autumn equinoxes. As the sun sets, the interplay of light and shadow on the northwestern balustrade creates the undulating illusion of a serpent slithering down the staircase to join its stone head at the base. This was the feathered serpent god Kukulkan descending from the heavens to earth. The pyramid was not just a temple, it was a stage for this divine manifestation, a piece of sacred theater that visually demonstrated the ruler's power to commune with the gods and reaffirm the cosmic order for all his people to see. For the Aztecs, who rose to power centuries later, this cosmic balance came at a much steeper, more terrifying price. They believed the universe had already been created and destroyed 4 times, and they lived in the 5th and final sun, the sun of movement. This sun, they believed, was set in motion through the self-sacrifice of the gods, but to keep it moving across the sky, to prevent the world from ending in a catastrophic earthquake, it required a constant offering of its own life force, human blood or chalchihuath, the precious liquid. The sun was literally nourished by sacrifice. This belief turned their capital, Tenochtitlan, into the site of some of the largest ritual ceremonies the world has ever known. During the reconsecration of the Great Pyramid in 1487, historical accounts suggest thousands of captives were sacrificed over 4 days. Their hearts were offered to the sun, and their bodies, believed to be filled with cosmic energy, were then treated with reverence. This practice, so brutal from a modern perspective, was for the Aztecs the ultimate act of cosmic loyalty, a grim necessity to pay the debt owed to the gods and sustain the very existence of the world. This perspective created a fundamentally different relationship with time itself. Unlike the Western concept of linear time, a straight arrow shooting from a beginning toward an end, the Maya and Aztecs saw time as a great sacred wheel composed of interlocking cycles within cycles. Their famous long count calendar measured vast epochs, but it was just one of several simultaneously running calendars. The Tzolk'in, a 260-day sacred round, intermeshed with the 365-day Hob to create a 52-year calendar round, a period of immense significance. The completion of this cycle was a time of tremendous anxiety, as it was believed the world could end if the rituals to kindle the new fire failed. This cyclical view meant that history was not a march of progress but a series of repeating patterns, of ages of creation and destruction governed by the stars. It was a worldview that emphasized renewal and repetition over linear advancement, inviting us to consider that our own way of measuring existence is just one of many possible interpretations of the cosmos's grand and mysterious rhythm. Far from the grand stone observatories and written records of urban empires, a different kind of astronomy flourished, one woven into the very land itself. Indigenous peoples across the world cultivated a celestial wisdom that was not separate from daily life but deeply embedded within it, a living knowledge passed down through generations in stories, songs, and the practical rhythms of survival. For these cultures, the sky was not a distant clock to be measured but an intimate partner in a continuous dialogue with the Earth. Their astronomical systems were exquisitely tailored to their specific environments, creating a science of place that connected every star, season, and animal behavior into a single, holistic understanding of the world. Consider the Aboriginal Australians, who have maintained the oldest continuous cultural tradition on Earth for over 65,000 years. Their night sky is not populated by Greek heroes but by animals, landscapes, and ancestral beings from the dreaming. One of the most famous examples is the emu in the sky, a constellation not made from stars but from the dark patches of the Milky Way, the cosmic dust clouds that silhouette the shape of a giant emu. When this celestial emu appears stretched out fully in the sky during the autumn months, it signifies that the real emus on the ground are foraging and fattening up, and that their eggs are not yet ready to be gathered. Later, as the Earth turns and the shape of the dark nebula appears to change, with the emu seeming to sit down or shrink, it signals that the eggs are now laid and it is the proper time to hunt for them. This is a profound form of ecological timekeeping, where the calendar is written in the negative space of the galaxy itself, directly linking a celestial pattern to a specific, sustainable harvesting practice. On the other side of the world, the Diné or Navajo people of the American Southwest see the Milky Way not as a river or a road, but as the sparkling trail of sacred pollen, the very essence of life scattered by the Black God as he organized the cosmos. They call it Yukesdahi, which translates to that which awaits the dawn. This glittering path is understood as the route that spirits travel upon death, a bridge between the earthly and the spiritual worlds. Their entire cosmology is built on the principle of Hajo, a complex concept of beauty, harmony, balance, and order that connects the individual to their community, their environment, and the universe. Their traditional Hogan dwellings are oriented east to welcome the rising sun, and their ceremonies are meticulously timed with celestial events to restore this balance. For the Navajo, astronomy is not about predicting the future but about maintaining a harmonious relationship with the present, ensuring that human actions are in step with the natural and celestial order. This approach stands in stark contrast to the formalized, often hierarchical astronomical systems of urban civilizations, where the Babylonians or Maya had priestly classes and written codices. Indigenous knowledge was typically democratic, oral, and practical. It belonged to everyone, taught to children through stories around the fire, and reinforced through ritual and art. A Polynesian navigator learned the star paths not from a book but from chance and years of apprenticeship on the open ocean. A Lakota elder would teach the story of the fall star not as a myth but as a map of morality and relationship. This was a science of memory and observation, refined over millennia and deeply attuned to local ecological cues. The stars told them when the salmon would run, when the caribou would migrate, or when the desert plants would bear fruit. This knowledge emphasized a cosmic loyalty not to a king or a state religion, but to the earth itself, a commitment to living in harmony with the land and its cycles, taking only what was needed and giving back in return. This deeply ecological perspective offers a crucial reminder that there is no single, monolithic way to know the sky. The universe is vast, and human cultures have interpreted its wonders through countless different lenses, each one valid, insightful, and beautifully adapted to its time and place. Indigenous astronomical traditions demonstrate that science and spirituality, practicality and poetry can be seamlessly intertwined. They teach us that the goal of understanding the cosmos might not be to conquer or control it, but to find our humble, harmonious place within its magnificent, interconnected web. This profound wisdom, earned through thousands of years of careful observation and respectful coexistence, provides a timeless lesson in cosmic loyalty that feels more urgent and relevant than ever in our modern world. While the Egyptians saw the cosmos as a divine mirror and the Maya as a living, layered universe, the ancient Greeks embarked on a revolutionary intellectual adventure, attempting to reconcile the celestial stories they inherited with a bold new spirit of rational inquiry. They stood at a unique crossroads, absorbing the detailed astronomical records of the Babylonians and the sacred geometry of the Egyptians, yet they asked a different kind of question. Instead of simply accepting that the gods directly moved the stars, they began to search for underlying principles, for natural laws that governed the cosmos. This was the dawn of philosophy, and it introduced a fascinating tension, a duality that would define Western thought for centuries. The Greeks, in their brilliance, refused to choose between myth and reason. They held both in their minds at once, creating a rich synthesis where the poetry of the stars coexisted with the pursuit of logical proof. This new way of thinking is perfectly embodied by the pioneering figure of Thales of Miletus, who lived in the 6th century before the Common Era. He is famously credited with predicting a solar eclipse in 585 BCE, an event that reportedly stopped a battle between the Lydians and the Medes. Whether he predicted it through inherited Babylonian cycle records or sheer genius, the significance was profound. Thales looked at an event that had always been seen as a terrifying omen from the gods and suggested it was a natural phenomenon, something that could be understood and even anticipated through observation and reason. He famously proposed that the earth floated on water and that water was the fundamental substance of all things, seeking a single, natural principle to explain the complexity of the world. This was a monumental shift from attributing thunder to Zeus's anger or the ocean's storms to Poseidon's wrath. Thales and his fellow Ionian philosophers were not necessarily atheists. They were simply looking for the mechanisms behind the divine will, the natural engine that drove the chariot of the sun across the sky. Yet, even as this radical new philosophy took root, the old stories refused to die. They were woven too deeply into the fabric of Greek identity, so the Greeks did something extraordinary. They maintained a dual system. In the same era that philosophers were debating the nature of matter, the poet Hesiod was writing Works and Days, a farmer's almanac that used the heliacal risings and settings of stars like the Pleiades to dictate the proper times for plowing and harvesting, all framed within a worldview of myths and gods. The constellation Orion remained a mighty hunter placed in the sky by Zeus, and the Milky Way was still the spilled milk of the goddess Hera. The myths provided a narrative, emotional connection to the cosmos, while philosophy sought an intellectual one. This wasn't seen as a contradiction. It was a richer, more complete way of engaging with the universe, satisfying both the heart and the mind. This duality reached its zenith in the contrasting worldviews of two of Athens' greatest thinkers, Plato and Aristotle. Plato, teaching at his academy, looked at the night sky and saw imperfection. He believed the messy, unpredictable wanderings of the planets were merely a flawed reflection of a higher, perfect reality, a realm of ideal, geometric forms. In his dialogue, Timaeus, he describes a divine craftsman who creates the universe based on perfect mathematical principles. The stars and planets, for Plato, were divine, eternal beings whose souls moved in perfectly circular orbits, the most noble and rational of paths. His cosmic loyalty was to this ideal, mathematical order behind the visible chaos. His student Aristotle took these ideas and built a vast physical model of the universe that would endure for nearly 2,000 years. In his system, the Earth sat motionless at the absolute center. Surrounding it were a series of 55 concentric, transparent crystalline spheres, each carrying the moon, the sun, the planets, and the fixed stars, all rotating around the Earth with perfect, uniform circular motion. This geocentric model was not just science, it was a complete cosmology that placed humanity at the physical center of God's creation, a deeply comforting and influential idea that would later be adopted and sanctified by the medieval church. But even within this dominant Earth-centered model, a few daring minds dared to imagine a different truth. A century after Aristotle, the brilliant astronomer Aristarchus of Samos looked at the available evidence and proposed a shocking idea. Perhaps the sun, not the Earth, was the center of the universe. Using ingenious geometry, he attempted to calculate the relative sizes and distances of the sun and moon. Though his measurements were inaccurate due to the limitations of his tools, his method was sound, and his conclusion was radical. He argued that the immense size of the sun made it more logical for the smaller Earth to orbit it. This heliocentric theory was simply too far ahead of its time. It challenged not only Aristotelian physics, but also the entire philosophical and religious framework that placed humanity at the center of everything. Without the necessary proof and in the face of overwhelming philosophical opposition, Aristarchus's idea was dismissed as implausible, a fascinating but forgotten footnote for over a millennium. The Greek synthesis, for all its brilliance, still had its limits, showing that even the most revolutionary ideas require a cultural moment ready to receive them. Their true legacy was not a single correct model, but the establishment of a dialogue, a never-ending conversation between the stories we tell about the heavens and the relentless, questioning search for the truth behind them. While the Greeks were weaving together myth and philosophy on the other side of the world, the Chinese Empire was perfecting a system where the cosmos and the state were two halves of an unbreakable whole. In ancient China, astronomy was never a mere academic pursuit. It was the ultimate state secret, the very foundation of political power and social order. The emperor, known as the Son of Heaven, did not rule by divine right in the distant way of European kings. His authority was a conditional lease, a sacred contract known as the Mandate of Heaven. This mandate was not inherited through bloodline alone. It was earned and maintained through virtue and, most importantly, confirmed by the heavens themselves. The sky was the ultimate report card on the emperor's performance, and any irregularity was a direct critique from the cosmos that could shake the empire to its core. To read this celestial feedback, the emperor employed a dedicated bureau of highly trained imperial astronomers. These were not stargazing poets, but elite civil servants and mathematicians working from sophisticated state-sponsored observatories. Their task was immense and relentless: to maintain a flawless, continuous record of the sky. Every night, they meticulously charted the predictable movements of the planets and the fixed stars. But their most critical duty was to spot the anomalies, the guest stars as they called them, which we now know were supernova, the sudden appearance of a comet with a long, ominous tail, or the terrifying, unexpected blackening of the sun during a solar eclipse. An event like the supernova of 1054, which created the Crab Nebula, was recorded in stunning detail by Chinese observers, noting its position and duration with scientific precision, even as they interpreted it as a potent political omen. These records were so meticulous that modern astronomers still use them today to study the long-term behavior of stars and other celestial phenomena, a testament to their astonishing accuracy. When a celestial warning sign appeared, the entire imperial machinery would swing into action. A solar eclipse was not a fascinating natural phenomenon. It was a catastrophe in the making, interpreted as a giant celestial dragon consuming the sun. It signaled that the emperor had lost the favor of heaven, perhaps through poor governance, moral failure, or a lack of piety. The response was a highly orchestrated ritual of atonement. The emperor would often issue a formal edict acknowledging his shortcomings and would fast and pray to restore harmony. Court astronomers would be tasked with calculating future eclipses to prove they could be predicted and thus, in a way, controlled, demonstrating the emperor's mastery over the cosmic order. If natural disasters or rebellions followed an eclipse, it was seen as confirmation that the mandate of heaven was withdrawing, potentially justifying the rise of a new dynasty that could restore balance. This made the court astronomers among the most powerful and pressured officials in the land, for their interpretations could literally make or break an emperor. This cosmic framework extended far beyond the palace walls and into the everyday life of every single person through the enduring system of the Chinese zodiac. Unlike the Western zodiac, which is based on the apparent path of the sun through constellations over 12 months, the Chinese zodiac is a 12-year cycle, with each year represented by an animal: the rat, ox, tiger, rabbit, and so on. This system is deeply intertwined with Chinese astronomy, linked to the 12-year orbit of the planet Jupiter around the sun. Your zodiac animal, determined by your birth year, is believed to influence your personality, your compatibility with others, and your fortune. For centuries, this has shaped decisions about marriage, business partnerships, and even the naming of children. It created a society where every individual's identity was, in a small way, connected to the grand, cyclical rhythm of the cosmos, fostering a personal sense of cosmic loyalty that mirrored the emperor's own duty to maintain heavenly order. This intricate dance between the celestial and the terrestrial, the imperial and the personal, forged a civilization uniquely attuned to the messages written in the stars, where looking up was not just an act of wonder, but one of survival, duty, and identity. Now let's voyage into the vast openness of the Pacific Ocean, where a different kind of celestial mastery took shape, one born not from stone observatories or imperial courts, but from the relentless rhythm of the waves and the unwavering patterns of the stars. The Polynesian explorers who settled the largest ocean on Earth achieved what many would have considered impossible. Without maps, compasses, or any metal instruments, they navigated thousands of miles of open water, discovering and colonizing hundreds of remote islands from Hawaii to New Zealand to Rapa Nui or Easter Island. Their vessel was the double-hulled canoe or waukolua, and their guide was a sophisticated science of wayfinding, a living astronomy where the navigator himself became the instrument and the entire ocean was his chart. This art of wayfinding, known as Haukul Kahiko in Hawaiian, was a holistic science that integrated celestial navigation with an intimate reading of the natural world. At its heart was a profound knowledge of the stars. A master navigator, or PWO, had memorized the precise rising and setting points of nearly 250 stars, creating a mental star compass that divided the horizon into 32 directional houses. He knew that the star known to us as Arcturus or Hokulea in Hawaiian passed directly over the Hawaiian Islands. As it moved across the sky, its position told him if he was north or south of his destination. Sirius or Kailua, the Queen of Heaven, was another key guidepost. The sky was not a static picture but a rotating dome, and each star was a reliable beacon that would appear in the same spot on the horizon night after night, season after season. As one star set, the navigator would simply pivot to the next one rising in the adjacent house, maintaining his course through an endless, rhythmic celestial dance. But their genius extended far beyond the stars. The sun and moon provided daytime direction, and their paths changed predictably with the seasons, information that was also encoded in oral traditions. When clouds obscured the heavens, the navigators turned to the ocean itself. They learned to read the subtle patterns of swells, the long, deep waves generated by distant weather systems and trade winds. By feeling the way their canoe rocked and rolled on these swells, they could maintain direction even in complete darkness. They observed the direction of the wind on their skin and the flight patterns of birds. The Monu Oku, or white tern, flies out to sea to fish in the morning but always returns to land at night. Following it could lead to an island just over the horizon. They even watched for signs in the clouds. A certain greenish tint on their undersides might reflect the lagoons of an atoll miles away, while a stationary pile of clouds often gathers over the high peaks of a volcanic island. This was not magic. It was a lifetime of accumulated, meticulous empirical observation, a data set held not in a book but in the mind and body of the navigator. This sacred knowledge was preserved through generations, not in written texts but through chants, songs, and stories. Young apprentices would spend years learning from a master, memorizing endless star sequences, wave patterns, and island lists through rhythmic oral recitation. These chants were more than simple mnemonics. They were the living library of Polynesian culture, containing history, genealogy, and the spiritual connection to the ancestors who had first sailed these routes. Loyalty to this ancestral knowledge was a matter of cultural survival. To forget a chant was to lose a star path, to sever a connection to a homeland, and to risk everything on the open ocean. The navigator was therefore the most revered member of the community, a holder of the collective memory, and the key to its future prosperity and expansion. For centuries, this incredible knowledge was nearly lost, a casualty of European colonization and the introduction of modern navigation tools. But in a powerful story of cultural revival, it has been spectacularly brought back to life. In the 1970s, a group in Hawaii sought to prove that these long voyages were intentional acts of exploration, not mere accidents of drift. They built a replica of a traditional voyaging canoe, named it the Hercules, and sought out one of the last remaining master navigators from Micronesia, Maupiailug. In 1976, using only the ancient stars, waves, and winds, Maupiailug successfully navigated the Hercules on a 2,000-mile voyage from Hawaii to Tahiti, a triumph that ignited a cultural renaissance across Polynesia. Today, a new generation of navigators continues this tradition, sailing thousands of miles across the Pacific and around the globe, not for necessity, but to honor their ancestors and to teach the world that there are many ways to know the world. This revival stands as a stunning testament to the accuracy and sophistication of indigenous science, a cosmic loyalty that views the heavens not as a distant clock to be measured, but as a familiar and trustworthy guide, a partner in the eternal human journey of discovery. While Europe was often described as being in its intellectual dark ages, a brilliant light of discovery was shining across the Islamic world, where scholars were not only preserving the knowledge of the ancients, but were actively revolutionizing it. This golden age of science, centered in great cultural capitals like Baghdad, Cairo, and Damascus, was fueled by a unique fusion of faith and reason. The Quran itself encouraged the study of the natural world as a way to understand the majesty of God's creation, and this spiritual imperative drove an unprecedented investment in knowledge. Caliphs established vast libraries and translation houses, most famously the House of Wisdom in Baghdad, where teams of scholars were commissioned to seek out and translate every great scientific work they could find, from the Greek texts of Ptolemy and Aristotle to the mathematical treatises of Indian astronomers. This monumental effort didn't just save this knowledge from being lost to history. It created a common foundation of learning that spanned continents, setting the stage for a period of explosive innovation in astronomy that would change the world. The practical needs of the Islamic faith provided a powerful, daily motivation for this astronomical revolution. Muslims are required to pray 5 times a day at specific intervals, marked by the sun's position at dawn, noon, mid-afternoon, sunset, and nightfall. Determining these precise moments, especially in different geographical locations with changing day length, demanded a sophisticated understanding of the sun's apparent motion. Furthermore, all prayers must be directed toward the Kaaba in Mecca, the holy city. This meant that no matter where a Muslim was in the vast, expanding Islamic empire from the Iberian Peninsula to the edges of India, they needed to know the exact direction, or Qibla, of Mecca from their location. This was not a simple matter of facing east or west. It required complex spherical trigonometry to calculate the great circle route across the curved surface of the Earth. This religious requirement directly spurred advancements in mathematics and the invention of incredibly precise instruments for observation and calculation. The most iconic of these tools was the astrolabe, a device that Islamic craftsmen transformed from a simple Greek concept into a breathtakingly complex and beautiful analog computer. Often made of intricately engraved brass, the astrolabe was a handheld model of the universe. By aligning its moving parts with the observed heights of certain stars or the sun, a user could tell the time day or night, calculate prayer times, determine the Qibla, and even forecast the positions of celestial bodies. It was an indispensable tool for the timekeeper of a mosque known as the muwaqqi't, and its design and function represent the perfect blend of art, science, and devotion. Beyond the astrolabe, Islamic scholars built massive, fixed observational instruments in dedicated observatories, like the Great Mural Quadrant, a giant quarter circle etched into a wall used at the Marrakech Observatory. These facilities, funded by rulers and staffed by full-time astronomers, allowed for a systematic, long-term study of the heavens that was unprecedented in its scale and accuracy. It was within this environment of rigorous observation and religious inquiry that true scientific giants emerged. Al-Battani, known in the West as Albatenius, meticulously corrected Ptolemy's calculations of the solar year and the precession of the equinoxes. His book of astronomical tables was so precise that it was used for centuries, even influencing the reform of the Julian calendar into the Gregorian calendar we use today. Then there was Abd al-Rahman al-Sufi, whose Book of Fixed Stars was a masterpiece of descriptive astronomy. He meticulously documented the stars, their positions, magnitudes, and colors, and he even included drawings of the constellations. Most remarkably, he made the first recorded observation of a galaxy other than our own, noting a little cloud in the constellation Andromeda, which we now know as the Andromeda Galaxy. These men, and countless others like them, were driven by a desire to create a perfect, accurate model of God's creation, believing that in understanding the clockwork of the universe, they were drawing closer to the divine clockmaker. This flourishing of science created an incredible legacy that was far more than just a preservation project. Islamic astronomers didn't just translate Greek texts. They identified their errors, improved their models, and added vast amounts of new empirical data. They developed the mathematical language of algebra and trigonometry that made these advanced calculations possible. When this colossal body of knowledge, along with the Arabic numerals we all use today, eventually made its way into Europe through places like Muslim Spain and Sicily, it ignited the spark of the Renaissance. European scholars, suddenly armed with 1,000 years of scientific advancement they never knew existed, began to build upon this foundation. The work of figures like al-Battani and al-Sufi provided the critical data and mathematical tools that would later allow Copernicus to reconsider the structure of the solar system. In this way, the cosmic loyalty of the Islamic Golden Age, a devotion to understanding the heavens both for religious practice and for the pure pursuit of knowledge, became the essential bridge that connected the astronomy of the ancient world to the scientific revolution that would eventually give rise to our modern understanding of the cosmos. As the vast intellectual networks of the Islamic world continued to advance astronomy, a very different picture was unfolding in medieval Europe. Here, the cosmos was not a realm of open inquiry to be measured and mastered, but a divinely ordered hierarchy, a perfect reflection of Christian theology and feudal society. The universe, as understood by a medieval scholar, was a place of profound meaning and strict boundaries, with humanity's spiritual home, the earth, sitting motionless at the absolute center of God's creation. This worldview was brilliantly systematized by the ancient Greek astronomer Ptolemy centuries earlier, but it was the medieval church that embraced his geocentric model and infused it with Christian purpose, turning the mechanics of the heavens into a grand symphony composed by the divine. This Ptolemaic system was a thing of intricate and beautiful geometry. Imagine the earth solid and unmoving, surrounded by a series of perfectly transparent, concentric crystalline spheres, each one nested within the next like a celestial onion. The moon occupied the closest sphere, followed by Mercury, then Venus, the Sun, Mars, Jupiter, and Saturn, the 7 known planets, a word derived from the Greek for wanderer. Beyond these, an 8th sphere held the fixed stars, all rotating together as a single, glittering tapestry. And beyond even that, a final, immovable sphere known as the primum mobile, or first mover, was believed to be set in motion directly by the hand of God, its perfect rotation imparting motion to all the inner spheres. This entire, magnificent apparatus was not just a scientific model, it was a theological statement. It placed humanity at the physical center of God's attention and explained the universe's operation as a continuous act of divine will, a perfect, harmonious dance that sang the glory of its creator. This cosmic architecture mirrored the social and spiritual structure of medieval life itself. Just as the spheres moved in perfect, unchanging order around the central earth, so too was society meant to be organized. The peasantry served the nobility, who served the king, who answered to God and his church. To suggest the earth was not the center was not merely a scientific error, it was a threat to this entire divinely ordained order. It was heresy. This theological constraint powerfully stifled innovation. Astronomers within the universities and monasteries were not tasked with questioning the model's fundamental truth, but with refining its complex details to better align with observed planetary motions, which were often frustratingly irregular. They developed elaborate systems of smaller circles, known as epicycles, revolving upon the larger spheres to explain the occasional retrograde motion of planets like Mars. This was a science of saving the phenomena, of making the observations fit the preordained conclusion, an intellectual exercise that could be brilliantly complex but was ultimately bound by dogma. Yet, even within these tight constraints, the flame of learning was kept alive. Monastic scriptoria painstakingly copied and preserved ancient texts, and in the emerging universities of cities like Paris and Oxford, scholars worked to synthesize classical knowledge with Christian doctrine. One of the most influential figures of this era was a humble English monk named Johannes de Sacrobosco. In the early 13th century, he wrote a short, clear, and incredibly persuasive text called Tractatus de Sphera, or On the Sphere of the World. This book did not present new discoveries. Instead, it brilliantly explained the Ptolemaic system, making the complex geometry of the celestial spheres accessible to generations of students. For centuries, De Sacrobosco's Sphera Mundi was the standard astronomy textbook across Europe. It educated minds from Dante Alighieri, who used its model as the literal architecture for his Divine Comedy, journeying through the spheres of heaven and hell, to a young Nicolaus Copernicus, who would first encounter the orthodox view through its pages. Sacrobosco's work shows that even a system designed to enforce conformity could also, perhaps unintentionally, train the very minds that would one day dismantle it. This period in European history presents a fascinating paradox. It was an age that produced breathtaking cathedrals whose spires reached symbolically toward heaven, and illuminated manuscripts that depicted the cosmos with stunning artistic detail. It was an era that deeply valued the order and beauty of the universe as a testament to God. Yet, that same reverence created an intellectual cage, a fear of questioning the celestial status quo that prevented any fundamental advancement in understanding for hundreds of years. The medieval European cosmos was a secure, knowable, and meaningful place, but its walls were made of dogma. The eventual cracking of those crystalline spheres would not come from a rejection of wonder, but from a new kind of curiosity, one that sought to understand the universe not by forcing it to conform to ancient texts, but by daring to observe it anew, no matter where the evidence might lead. For centuries, the universe had a clear and comforting address. Earth was at the center. This wasn't just a scientific fact. It was a theological certainty, a social cornerstone, and a cosmic validation of humanity's singular importance. The entire magnificent crystalline machinery of the Ptolemaic system, with its complex epicycles and divine spheres, existed to revolve around us, placing our world at the very heart of God's creation. This geocentric view was more than a model. It was the bedrock of reality, endorsed by the authority of both the ancient Greeks and the medieval church. To question it was to question the very order of the universe and humanity's privileged place within it. Yet, in the quiet study of a Polish canon and mathematician named Nicolaus Copernicus, a revolutionary idea began to take shape, one so profound it would eventually shatter that foundational worldview and redefine our entire relationship with the cosmos. Copernicus was a man of his time, deeply immersed in the classical knowledge preserved and advanced by Islamic scholars. As he studied the existing planetary models, he grew increasingly frustrated with their complexity. The system of epicycles upon epicycles required to explain the observed retrograde motions of the planets seemed, to him, clumsy and unnatural. He began to explore an ancient idea that had been dismissed for over a millennium. What if the sun, not the Earth, was at the center? Using the same observational data available to Ptolemy, Copernicus worked for decades on a new mathematical model. He found that by placing the sun at the hub, the motions of the planets could be explained with far greater elegance and simplicity. The confusing retrograde loops of Mars and Jupiter were no longer actual celestial acrobatics, but a simple illusion caused by our own moving Earth overtaking them on an inner orbital track. This heliocentric model was a stunning intellectual achievement, a testament to the power of reason and mathematics to reveal a deeper, hidden truth about the universe's architecture. But Copernicus understood the explosive implications of his work. His book, On the Revolutions of the Heavenly Spheres, was a truly revolutionary text, yet he reportedly held the finished manuscript for years, only allowing it to be published as he lay on his deathbed in 1543. His hesitation was well-founded. His idea was not merely a technical correction. It was a direct assault on the cosmic loyalties that held medieval society together. By dethroning the Earth from the center of creation, Copernicus was implicitly dethroning humanity itself. If our world was just another planet circling the sun, then what became of the unique relationship between God and man? What of the divine hierarchy that placed the heavens above and the earth below? The Church's entire intellectual framework, which had seamlessly blended Aristotelian physics with Christian doctrine, was suddenly under threat. The revolution he began was not just astronomical, it was philosophical, theological, and profoundly psychological, forcing a humbling re-evaluation of our significance in a vast and impersonal universe. For decades, the Copernican model remained a controversial but largely theoretical alternative, a mathematician's elegant hypothesis. It took the invention of the telescope and the bold observations of Galileo Galilei to turn theory into undeniable evidence. Pointing his new instrument toward the heavens in 1609, Galileo saw things no human had ever seen before. He discovered 4 moons orbiting Jupiter, a clear miniature solar system that proved not everything revolved around the Earth. He observed the phases of Venus, which mirrored those of our moon, providing direct proof that Venus was indeed orbiting the Sun. He saw mountains and craters on our own moon, revealing a celestial body that was not a perfect, smooth sphere as Aristotelian doctrine demanded, but a world as complex and imperfect as our own. Galileo's discoveries, published in his widely read Starry Messenger, were a sensation. He didn't just have mathematical models, he had eyewitness testimony from the sky itself, evidence that made the old cosmology untenable. This evidence, however, placed Galileo on a direct collision course with the Church authorities. Here was not a quiet scholar publishing a dense Latin tome, but a brilliant and often combative publicist for the new science, writing in accessible Italian to reach a broad audience. The Church, already embattled by the Protestant Reformation, saw this challenge to its interpretative authority over the natural world as a dangerous threat. In 1616, the Vatican declared the heliocentric theory foolish and absurd in philosophy and formally heretical. Galileo was ordered to abandon its support. For years he complied, but eventually he published another work, Dialogue Concerning the Two Chief World Systems, which, despite its pretense of neutrality, made a powerful and mocking case for the Copernican view. The result was the infamous trial of 1633, where the aging scientist was forced to recant his beliefs on his knees under threat of torture and was sentenced to house arrest for the remainder of his life. His personal tragedy became the defining symbol of the struggle between established dogma and emerging empirical science, a stark warning of the personal cost that can accompany a shift in cosmic loyalty. Despite the Church's powerful resistance, the genie was out of the bottle. The evidence was too compelling, the mathematical elegance of the heliocentric model too persuasive. The work of later astronomers like Johannes Kepler, who discovered the elliptical orbits of planets, and Isaac Newton, who provided the universal law of gravity that explained why they moved, cemented the Copernican revolution in place. The Earth was indeed a planet, and the Sun was its star. This was more than a scientific victory. It was a monumental shift in human consciousness. It required immense intellectual courage to accept a truth that demoted humanity from the center of the stage to a participant in a much grander, vaster drama. This shift reminds us that our understanding of the universe is not static, that cosmic loyalty is not about blind adherence to inherited beliefs, but about having the courage to follow the evidence, no matter how disorienting or humbling the conclusions may be. The courage of Copernicus to calculate, of Galileo to observe, and of countless others to believe them, fundamentally altered our place in the cosmos and set the stage for an entirely new era of questioning and discovery. The triumph of the Copernican revolution did more than just rearrange the solar system. It fundamentally rewired the human mind, setting the stage for an era of unprecedented intellectual daring. The 17th and 18th centuries, known as the Age of Enlightenment, witnessed a profound shift in our cosmic loyalty, moving from a posture of reverent obedience to one of bold, empirical interrogation. Thinkers and scientists began to insist that the universe was not a divine mystery to be accepted on faith, but a magnificent machine whose laws could be discovered through reason, observation, and mathematics. This was the great disenchantment of the sky, a process where the constellations slowly shed their mythological skins and were reborn as physical objects governed by knowable, universal principles. The celestial sphere, once the animated home of gods and spirits, was gradually transformed into a vast, silent clockwork, its mysteries not locked away in sacred texts but written in the elegant language of physics. No single figure embodies this seismic shift more completely than Sir Isaac Newton. With the publication of his Philosophiae Naturalis Principia Mathematica in 1687, he provided the universe with its operating manual. His law of universal gravitation was a revelation of breathtaking simplicity and power. The very same force that caused an apple to fall from a tree in his garden in Lincolnshire also held the moon in its orbit around the Earth and the Earth in its path around the Sun. This was a stunning unification of the celestial and the terrestrial realms, which had been considered separate and distinct since the time of Aristotle. There was no longer a need for angels or divine intelligences to push the planets along their paths. A single mathematical equation could explain it all. Gravity acted as an invisible mechanical hand, guiding the cosmic dance with impersonal and perfect regularity. The heavens were demystified, their motions made predictable and mundane, their wonder transferred from the realm of story into the realm of calculation. This new mechanical universe was both exhilarating and, for many, deeply unsettling. The poetic, narrative quality of the night sky, which had provided comfort and meaning for millennia, began to evaporate. The stars were no longer the eternal campfires of ancestors or the watching eyes of gods. They were now distant suns, immense balls of incandescent gas governed by the same cold, physical laws as everything else. For the poets and the romantics, this felt like a loss, an alienation from a cosmos that now seemed indifferent to human affairs. The German philosopher Friedrich Schiller would later lament this disenchantment of the world, the feeling that the universe had been stripped of its soul and its story. The sky became a subject for study rather than worship, an object of intellectual conquest rather than spiritual communion. Yet, within this disenchantment lay the seeds of an even greater, more humbling kind of enchantment. Freed from the constraints of earth-centered theology, the human imagination began to speculate on a scale never before possible. The German philosopher Immanuel Kant, gazing at the fuzzy patch of light in the constellation Andromeda, proposed a radical idea. He called it an island universe, a vast, distant collection of stars, a separate galaxy entirely distinct from our own Milky Way. He speculated that the universe was filled with such galaxies, each a swirling metropolis of suns and likely worlds, a concept that was almost unimaginably vast. This was no longer just about our solar system. It was about the cosmos, an infinite arena whose true scale and structure were only beginning to be glimpsed. The disenchantment of the local sky re-enchanted the entire universe, opening up frontiers of space and time that made the old mythological cosmos seem quaint and small by comparison. This duality, the loss of ancient narratives paired with the gain of profound new understanding, perfectly characterizes the origins of modern astronomy. The rational, mechanical approach pioneered by Newton and the speculative courage of thinkers like Kant unlocked mysteries that had been completely inaccessible to the stargazers of the past. The nature of light, the composition of stars, the force of gravity, the very fabric of space-time, all became subjects of rigorous inquiry. This shift from spiritual to intellectual loyalty enabled the technological advances that would define the modern world, from accurate sea navigation to the eventual exploration of space itself. It was a difficult but necessary trade-off. We exchanged a familiar, story-filled cosmos that revolved around us for a vast, impersonal, and infinitely more fascinating universe in which we found our true, humble place not at the center, but as conscious participants in an epic of cosmic evolution. If the Enlightenment taught us that the heavens operate by universal physical laws, the 19th and 20th centuries revealed what those heavens are actually made of, transforming stargazing from a study of motion into a study of matter and energy itself. This was the birth of astrophysics, a new science that didn't just chart the paths of celestial objects but sought to understand their very nature, their birth, their life, and their ultimate death. The key that unlocked this cosmic chemistry set was a seemingly simple discovery. That light, when split apart, contains the hidden fingerprints of the elements. This technique, called spectroscopy, became the most powerful tool in the astronomer's kit, turning every point of light in the night sky into a readable biography written in the unique language of atoms. The breakthrough began not in an observatory but in a laboratory. In the 1850s, chemist Robert Bunsen and physicist Gustav Kirchhoff were experimenting with heating different chemical elements to incandescence in Bunsen's now famous burner. They found that each element, when vaporized, produced a unique set of bright, colored lines when viewed through a prism, a spectral barcode unique to that substance. Sodium always produced a distinctive pair of yellow lines. Lithium created a brilliant crimson line. They had discovered that every element has its own atomic signature. Then came the revolutionary leap. When they pointed their spectroscope at the sun, they saw the same patterns, but with a crucial difference. The bright lines were now dark, like black gaps in the rainbow. Kirchhoff realized this meant the sun's blazing core was producing a continuous spectrum of light, but its slightly cooler outer atmosphere was absorbing specific wavelengths, leaving behind these dark absorption lines. For the first time in human history, we could determine the chemical composition of a distant object millions of miles away simply by analyzing its light. We learned that the sun is made of hydrogen and helium, the same substances found right here on Earth. The message was profound and humbling. The laws of chemistry are universal. This revelation cascaded through the scientific world, shattering ancient assumptions. Suddenly, astronomers could analyze the light from any star and know what it was made of. They discovered that stars are, in fact, other suns. Our sun is not a unique entity but a rather average star, one of countless others, all governed by the same physical principles. This realization was a double-edged sword of cosmic perspective. On one hand, it completely demystified the stars, reducing them from divine lanterns or the souls of ancestors to immense nuclear-powered furnaces. On the other hand, it revealed a universe of staggering scale and beauty. By measuring subtle shifts in these spectral lines, astronomers could also calculate a star's motion toward or away from us, its temperature, its density, and even its mass. The sky was no longer a silent, two-dimensional tapestry. It was a dynamic, three-dimensional ocean of diverse and evolving suns, each with its own story told in the subtle shifts of its light. This new, evidence-based understanding of the cosmos gave rise to a different kind of cosmic loyalty, a devotion not to ancient stories or divine mandators, but to scientific truth and the relentless, collaborative pursuit of exploration. The awe once reserved for gods was now directed at the sheer grandeur of natural laws and the human ingenuity required to uncover them. No one embodied this new synthesis of wonder and rationality better than the astronomer Carl Sagan. Through his iconic 1980 television series, Cosmos, he took these complex discoveries about the life cycles of stars, the vastness of galaxies, and the origins of life itself, and translated them into a powerful, poetic narrative for hundreds of millions of people. He didn't just present facts, he framed them within a cosmic context, reminding us that we are literally made of stardust, that the atoms in our bodies were forged in the hearts of long-dead stars and scattered across the galaxy in stellar explosions. This was a powerful, evidence-based creation myth, a story that connected us physically to the universe in a way no ancient mythology ever could. Sagan became the high priest of this new scientific worldview, advocating for a sense of reverence that was not opposed to reason but was born from it. He argued that science itself is a source of profound wonder, and that our ability to comprehend the cosmos is one of the most meaningful aspects of our existence. This era demonstrates that science, in its quest to demystify, does not necessarily destroy mystery, it simply relocates it. The old mysteries of why the stars move were replaced by new, deeper mysteries about dark matter, black holes, and the origin of the universe itself. The mythology that astrophysics created is one built on evidence, peer review, and testable hypotheses, yet it is every bit as epic and inspiring as the tales of Orion or Isis. It tells of giant stars collapsing into unimaginably dense neutron stars, of black holes where gravity is so strong that not even light can escape, and of a universe that began in a fiery Big Bang nearly 14 billion years ago. These are the stories we tell now, and they inspire their own form of loyalty, a commitment to curiosity, to critical thinking, and to the shared human project of exploration. As our telescopes peer deeper into space and further back in time, we continue this ancient human tradition, not by seeking messages from gods in the stars, but by seeking to understand our own place within a vast and astonishing physical reality, finding meaning in the very act of seeking itself. Today, the quest to understand the cosmos is powered by technology our ancestors could never have imagined. Giant radio telescopes listen to the faint whispers of the Big Bang. Space-based observatories like Hubble and the James Webb peer back in time to the dawn of the first galaxies, and incredibly sensitive instruments like LIGO and Virgo feel the subtle ripples in spacetime caused by colliding black holes billions of light-years away. Professional astronomy has become a data-driven science of the profoundly vast and incredibly ancient, revealing a universe that is stranger and more wonderful than any mythology. We can map the distribution of dark matter, watch stars being born in stellar nurseries, and identify thousands of planets orbiting distant suns. This is the pinnacle of empirical discovery, a testament to human reason and ingenuity that has unlocked secrets of the universe once thought to be forever beyond our grasp. Yet, in parallel with this high-tech exploration, a powerful and poignant cultural countercurrent is flowing. There is a growing, collective yearning to reconnect with the night sky in a way that is more personal, more visceral, and more rooted in story. This isn't a rejection of science, but rather a desire to complement data with meaning, to pair the how with the why. Around the world, indigenous communities are leading a profound revival of their traditional astronomical knowledge, reclaiming celestial stories and practices that were nearly erased by colonization. In North America, Navajo and Lakota educators are teaching young people the constellations not as Greek heroes, but as spiritual guides and ecological markers. In Australia, Aboriginal elders are sharing the stories of the emu in the sky, ensuring that this ancient, sustainable knowledge of the land and seasons is passed on. This movement is about cultural survival, a reassertion of identity that is written in the stars themselves. This revival extends far beyond indigenous communities, resonating with a broad audience of amateur stargazers and city dwellers who feel a sense of loss under light-polluted skies. The popularity of astronomy apps, community star parties, and ecotourism centered on dark sky locations speaks to a deep, universal hunger for direct experience. People are traveling to remote deserts and mountains not just to see more stars, but to feel something, to experience the awe and humility that comes from standing under a truly dark, star-filled sky. It is an attempt to recapture that primal connection, to experience the Milky Way not as a picture on a screen, but as a brilliant, arching river of light so vivid it feels almost tangible. This is a low-tech wonder that requires nothing more than looking up with your own eyes, yet it offers a profound sense of perspective and place that can be life-changing. A critical ally in this movement is the fight against light pollution, led by organizations like the International Dark Sky Association. The proliferation of artificial light has not only disconnected 80% of humanity from the view of our own galaxy, but it also disrupts ecosystems, wastes energy, and impacts human health. The creation of dark sky preserves and parks protected areas where lighting is strictly controlled to preserve the natural night environment is a practical and philosophical stand. These places are more than just astronomical observing sites. They are sanctuaries for natural darkness, preserving a fundamental human experience for future generations. Supporting these efforts is a modern act of cosmic loyalty, a commitment to ensuring that the awe-inspiring spectacle that guided and inspired our ancestors remains accessible, reminding us that we are part of a larger universe, not separate from it. What we are witnessing is the emergence of a holistic 21st-century cosmic loyalty. It is a worldview that refuses to choose between the telescope and the myth, between the data set and the story. It understands that the equations describing a supernova are magnificent, but so is the indigenous story that sees that same explosive stellar death as the scattering of life-giving elements across the cosmos. We can hold both truths simultaneously. We can marvel at a Hubble image of a nebula while also learning the Polynesian star path that bears its name. This integrated perspective enriches our understanding, allowing us to appreciate the universe not just as a physical system to be decoded, but as a source of endless wonder that nourishes both our intellect and our spirit. This beautiful synthesis suggests that our relationship with the cosmos is not a straight line of progress from superstition to science, but rather a spiral, returning to ancient themes of connection and meaning, but now informed by a deeper, evidence-based awe. In an age where we carry supercomputers in our pockets and have mapped the human genome, the daily ritual of millions checking their horoscope might seem like a baffling paradox. We live bathed in the light of scientific discovery, yet a significant portion of the population still glances toward the stars for personal guidance, seeking meaning in the ancient positions of planets. This isn't a simple rejection of science, but rather a testament to a different, deeply human need, a longing for a personalized narrative within the vast, impersonal cosmos. Astrology, in its modern form, fulfills a role that data and equations cannot. It offers a framework for understanding ourselves and our place in the universe that is intimate, accessible, and rich with story. The core mechanics of astrology are a direct inheritance from the celestial loyalty of our ancestors, particularly the Babylonians who first codified the Zodiac. They mapped the sun's path through 12 constellations, creating a symbolic language where each segment of the sky carried specific qualities. A planet's movement through these signs wasn't just an orbit. It was a dynamic conversation between cosmic forces, influencing events on Earth. Modern Western astrology has streamlined this ancient system, focusing primarily on the position of the sun, moon, and planets at the exact moment of a person's birth to create a unique natal chart. This chart is read not as a deterministic fate, but as a map of innate potentials, personality traits, and life themes. It's a language of archetypes, the assertive energy of Mars, the expansive nature of Jupiter, the disciplined structure of Saturn, that provides a vocabulary for self-reflection. In a world that can often feel chaotic and random, this astrological framework imposes a sense of order and pattern. It suggests that our lives are not a series of random accidents, but are part of a larger, meaningful cosmic story, offering comfort and a sense of purpose to those who feel adrift. This psychological function is arguably the most powerful driver of astrology's persistent appeal. Carl Jung, the founder of analytical psychology, recognized this power, introducing the concept of synchronicity, a meaningful coincidence that cannot be explained by cause and effect. He saw astrology not as a literal science but as a valuable symbolic system that could tap into the unconscious mind and provide insights into personality and life patterns. From this perspective, reading a horoscope or analyzing a birth chart is a form of modern-day myth-making. It allows individuals to project their anxieties, hopes, and experiences onto a cosmic canvas, organizing the complexities of their inner world into a structured and relatable narrative. When someone reads that a Mercury retrograde period might bring communication breakdowns, it provides a ready-made story to explain a week of missed emails, technological glitches, and misunderstandings. This isn't necessarily about believing a planet is causing havoc, but about finding a shared cultural story that makes sense of life's frustrations, reducing anxiety by offering a reason and even a time frame for the chaos. Furthermore, astrology fosters a powerful sense of community and identity in an increasingly fragmented world. The simple question, "What's your sign?" is a universal social lubricant, a quick way to categorize and connect with others. Online, this has exploded into vast digital communities where people gather to discuss their charts, share memes about the struggles of their zodiac sign, and find solace in the notion that certain challenges or traits are cosmically ordained. This creates a sense of belonging to something larger than oneself. Identifying as a passionate Scorpio or a pragmatic Capricorn provides a pre-packaged identity kit, complete with strengths, weaknesses, and famous representatives. It's a tool for building self-awareness and for feeling understood within a group that speaks the same symbolic language. This communal aspect transforms astrology from a solitary belief into a shared cultural practice, a form of secular spirituality that offers connection without the requirements of formal religion. Of course, the scientific community consistently and forcefully rejects astrology's claims, classifying it as a pseudoscience because its core principles have no basis in tested physical laws, and its predictions are consistently shown to be no more accurate than chance. The gravitational or electromagnetic influence of a distant planet on a newborn baby is negligible compared to the influence of a doctor's hand in the delivery room. Critics argue that its descriptions are so vague and general that they can apply to anyone, a psychological phenomenon known as the Barnum effect. Yet, its continued prevalence despite these cogent criticisms highlights that its value for millions of people is not rooted in empirical proof, but in emotional and psychological utility. Astrology persists not because it explains how the universe works in a physical sense, but because it answers a more ancient, enduring human question: why does it matter? It represents a form of cosmic loyalty that prioritizes meaning over mechanism, story over data, and connection over isolation, proving that even in our hyper-rational modern world, we still look to the stars not just for answers, but for a sense of belonging in the great, unfolding story of existence. But how do we know any of this? How can we be so certain about what ancient people saw in the stars when they left behind no written manuals or guidebooks? The answer lies in a fascinating and relatively young scientific field that acts as a bridge across millennia, a discipline known as archaeoastronomy. This is the detective work of the cosmos, where astronomers team up with archaeologists, anthropologists, and historians to reverse engineer the celestial knowledge of our ancestors. It's not about guessing, it's about measuring, calculating, and observing, using the same sky they did to understand the profound structures they left behind. Take, for example, the massive 5,000-year-old tomb mound at Newgrange in Ireland. To the casual observer, it's an impressive feat of Neolithic engineering, a grass-covered hill of stone. But every year around the winter solstice, something miraculous happens. As the sun rises on the shortest day of the year, a single, narrow beam of sunlight penetrates through a specially designed roof box above the entrance, travels down a long, dark passageway, and for exactly 17 minutes illuminates the inner burial chamber deep within the heart of the mound. This is not an accident. The builders designed this structure with an astonishing precision that required generations of observation to align the entrance, the passage, and the chamber with the precise rising point of the sun on that one critical day. For a farming society, the winter solstice marked the symbolic death and rebirth of the sun, the promise that the light would return and the seasons would turn again. By bringing that reborn sun into the house of their ancestors, they were forging a direct, tangible link between the cycles of the cosmos, the spirits of the dead, and the survival of the living community. This is cosmic loyalty etched in stone and sunlight. On the other side of the Atlantic, in the high desert of New Mexico, another sophisticated astronomical culture left its mark. The ancestral Puebloan people of Choco Canyon constructed a sprawling complex of great houses and ceremonial kivas over 1,000 years ago. From the air, the layout of their buildings reveals a sophisticated awareness of celestial patterns. At the Great House of Casa Rinconada, a large, underground kiva features two niches in its wall. On the summer solstice, a shaft of sunlight enters through a window and strikes one niche. On the winter solstice, it illuminates the other. But perhaps their most stunning achievement is a spiral petroglyph carved high on a canyon wall behind their great house of Pueblo Bonito, known as the Sun Dagger. For centuries, this carving was just an interesting rock art. Then, in the 1970s, an artist and researcher named Anna Sofer discovered its true purpose. She observed that at summer solstice, a slender dagger of sunlight bisects the center of the spiral. At the winter solstice, two daggers of light perfectly bracket it. And during the equinoxes, a dagger of light splits a larger carved spiral nearby. This was a sophisticated solar calendar, a precise way of marking not just the solstices, but also the midpoints between them, crucial for timing ceremonies and agricultural cycles. The Chacon people integrated their architecture with the very landscape to create a giant, interactive celestial clock, demonstrating a deep, practical, and spiritual connection to the sky's rhythms. Beyond confirming the incredible engineering feats of the past, archaeoastronomy plays a vital role in cultural reclamation and respect. For many indigenous communities, their astronomical knowledge was systematically suppressed or dismissed as myth by colonizers. The work of archaeoastronomers, often done in close collaboration with these communities, helps to validate and preserve this knowledge, proving it was a sophisticated science developed over thousands of years. It's a powerful form of restorative justice, returning a sense of intellectual pride and correcting the historical record. This collaborative approach fosters a profound respect for diverse ways of knowing. It shows us that the scientific method, with its strict hypothesis and measurement, is just one path to understanding the universe. The ancestral Puebloans or the builders of Newgrange had a different path, one that wove together careful empirical observation with spiritual meaning, seeing the physical and the sacred as inseparable parts of a unified whole. Ultimately, this field does more than just decode ancient buildings. It holds up a mirror to our own perpetual human quest. By studying the lengths to which our ancestors went to track the stars, to build monuments in alignment with them, and to weave them into their most sacred stories, we see a universal drive to find our place in the cosmos. That drive is just as strong in us today. We may have space telescopes and supercomputers instead of stone circles and sun daggers, but the fundamental questions remain the same. Where did we come from? What is our purpose? Are we alone? Archaeoastronomy teaches us that this search for meaning is a constant thread in the human story. It enriches both history by showing us the intellectual brilliance of past cultures and astronomy by grounding our modern science in a deep human context. It reminds us that our journey to understand the universe is not a new one, but an ancient and ongoing conversation between humanity and the heavens, a conversation written in the very alignment of stones against the endless turning of the sky. Long after the campfire stories of hunters and gods were first told, the night sky found a new home in the pages of books and on the canvases of painters, becoming a mirror for the deepest fears and highest hopes of the human spirit. This artistic engagement with the cosmos offers a parallel history to the scientific one, a record of our emotional and philosophical relationship with the universe that is just as vital and revealing. When Dante Alighieri penned his Divine Comedy in the 14th century, he didn't just use the stars as a pretty backdrop. He used the entire Ptolemaic universe as the literal architecture for his epic journey. His protagonist travels through the concentric spheres of the Moon, Mercury, Venus, and onward, each higher level bringing him closer to the divine light of God. For Dante, the cosmos was a perfect, hierarchical, and deeply religious structure, a physical manifestation of a moral and spiritual order. His cosmic loyalty was one of faith and divine love, and his work stands as a breathtaking synthesis of medieval astronomy, theology, and poetry, showing how the sky could serve as a map for the soul's journey. Centuries later, as the Enlightenment began to rationalize the heavens, the artistic response shifted from religious awe to a more personal, often troubled, sense of wonder. The Romantic poets of the 18th and 19th centuries looked up at the same stars and saw not the hand of a benevolent god, but the face of a sublime and terrifying infinity. For William Wordsworth, the starry sky was a source of pure, almost painful beauty that could transport him beyond the mundane world. In his sonnet, he writes of being silent upon a peak in Darien, overwhelmed by the spectacle. But for others, this vastness could evoke a profound sense of isolation. The German poet Friedrich Hölderlin grappled with the ethereal abyss, feeling both drawn to and terrified by the infinite void. This romantic cosmic loyalty was deeply individualistic, a search for meaning and emotion in a universe that science was increasingly revealing to be cold, mechanical, and impersonal. The stars became symbols of a lost connection, a beauty that was magnificent but ultimately indifferent to human struggles. This tension between beauty and terror, connection and alienation, reached its explosive peak in the post-impressionist era with Vincent van Gogh's iconic painting, The Starry Night. Painted from the window of his asylum room in Saint-Rémy-de-Provence, the work is not a realistic depiction but a violent, emotional interpretation. The sky is alive with swirling, turbulent energies. The stars and moon radiate immense halos of light, and a strange, blue-black cypress tree writhes like a flame in the foreground, connecting the earthly to the celestial. This is not a peaceful, ordered universe. It is a cosmos pulsating with a chaotic, almost frightening vitality. Van Gogh's cosmic loyalty was not to doctrine or reason, but to raw feeling. He saw in the night sky a reflection of his own tormented inner world, a place of intense beauty and equally intense turmoil. His painting captures the modern existential condition, the individual alone, gazing into an incomprehensibly vast and dynamic universe, trying to find a personal anchor point within the storm. This subjective, emotional connection to the cosmos remains a powerful force in contemporary art and literature, often serving as a counterbalance to the sometimes sterile language of pure science. Modern poets like Tracy K. Smith, in her Pulitzer Prize-winning collection Life on Mars, use the imagery of space exploration and the cosmos to grapple with very earthly grief and the mystery of her father's death, who worked on the Hubble Space Telescope. For her, the cosmos becomes a vast metaphor for the unknown, for loss, and for the search for connection across an impossible distance. Similarly, filmmakers like Andrei Tarkovsky in his science fiction masterpiece Solaris use the alien and the cosmic to explore the inner landscapes of human memory, guilt, and love. The sentient ocean planet in the film is not just a setting, it is a mirror that forces the characters to confront their own deepest selves. This artistic tradition proves that our cosmic loyalty is not monolithic. It can be spiritual, emotional, psychological, or existential, providing a rich tapestry of interpretations that scientific data alone cannot satisfy. By tracing this creative legacy from Dante's ordered heavens to Van Gogh's chaotic whirlwinds, we see a clear evolution in cultural attitudes. We moved from a collective, faith-based understanding of the universe to a highly individual, often anxious, search for meaning within it. Yet, certain universal themes remain stubbornly constant across the centuries. The feeling of awe when confronted with the Milky Way's shimmering band, the spark of curiosity about what might lie beyond our own world, and the primal fear of that infinite darkness. This artistic engagement ensures that the night sky is never reduced to a collection of data points. It remains a living, breathing source of inspiration, a canvas upon which every generation projects its greatest questions, its deepest fears, and its most hopeful dreams, guaranteeing that the stars will always have a story to tell. This ancient understanding of the cosmos as a deeply interconnected system, where human well-being was inseparable from the health of the land and the rhythms of the stars, offers a profound and urgently needed perspective for our modern ecological crises. For indigenous cultures worldwide, this wasn't a philosophical abstraction but a practical, lived reality. The Aboriginal Australians who timed their emu egg gathering by the shape of the dark nebulae in the Milky Way, or the Native American tribes who used the heliacal rising of the Pleiades to signal the start of planting season, were practicing a form of cosmic loyalty that demanded environmental stewardship. Their survival depended on reading the subtle cues of the ecosystem, which were themselves reflected in the celestial cycles. They saw the earth and the sky not as separate realms, but as a single, breathing organism. To harm the land was to disrespect the carefully balanced order of the heavens themselves. It was a violation of a sacred contract with the universe. This timeless wisdom finds a startlingly similar echo in the most modern of human experiences, the view of Earth from space. Astronauts who have journeyed beyond our atmosphere consistently report a powerful cognitive shift known as the overview effect. From the vantage point of orbit, national borders vanish, and the planet reveals itself as a stunning, fragile blue marble suspended in the immense black void. They describe an overwhelming sense of interconnectedness, a realization that every forest, ocean, and city is part of a single, delicate biosphere with no backup plan. This isn't just an intellectual understanding, it's a visceral, emotional awakening, a feeling of profound responsibility for this beautiful, isolated world. The astronaut Edgar Mitchell called it a feeling of instant global consciousness. This modern epiphany, born of technology, mirrors the foundational principle of many ancient cosmologies, that everything is connected and that our primary loyalty must be to the health of the whole system. This convergence of ancient star-based wisdom and contemporary space-age insight invites us to reframe our entire approach to environmentalism. Rather than seeing it as a political issue or a burdensome sacrifice, we can understand it as a new form of cosmic ethics, a loyalty not just to our local community or nation, but to the planet as a whole, which is itself a participant in a vast cosmic dance. When we pollute a river, we are not just breaking an environmental regulation. We are disrupting a cycle that is mirrored in the hydrologic loops of other worlds and celebrated in the celestial myths of our ancestors. When we accelerate climate change, we are not merely altering our weather. We are failing in our duty as conscious stewards of a rare and precious planet, a duty that is the very essence of the overview effect. This perspective elevates environmental action from a matter of policy to a matter of principle, rooted in a deep-time understanding of our place in the universe. By consciously reviving these holistic views, we can begin to address our ecological challenges with a wisdom that is both radically new and ancient. This means listening to and elevating indigenous knowledge systems that have sustained human societies for millennia. It means designing our cities and economies to mimic the cyclical, waste-free patterns we observe in nature and the cosmos, moving from a linear model of extraction and consumption to a circular one of renewal and reciprocity. It means educating a new generation to see the night sky not as a distant curiosity, but as the original map for living in balance on Earth. This approach doesn't require us to abandon science and technology, but rather to guide them with a different ethos, one that values harmony over domination and long-term cosmic loyalty over short-term gain. The future of our planet may depend on our ability to merge the oldest stories written in the stars with the newest data from our satellites, creating a sustainable path forward that honors both the wisdom of the past and the responsibility we carry into the future. Imagine holding the entire universe in the palm of your hand. With a few swipes on a smartphone, you can zoom in on the swirling storms of Jupiter, fly through the pillars of creation in a nebula thousands of light years away, or track the International Space Station as it glides silently over your hometown. This is the reality of virtual astronomy, a technological revolution that has democratized access to the cosmos in ways our ancestors could never have conceived. Sophisticated planetarium apps like Stellarium or Sky Safari transform your device into a dynamic star chart, automatically identifying constellations and planets based on your location and time. For those without access to a physical telescope, online observatories like SLU or the Micro Observatory Robotic Telescope Network allow users to book time on powerful professional instruments located in dark site locations around the globe, capturing their own images of distant galaxies from the comfort of their living room. This unprecedented access has blown open the doors of astronomy, inviting millions of curious minds to become explorers, regardless of their budget, physical ability, or proximity to light pollution. Yet, this digital convenience carries a subtle but significant cost: the potential loss of that primal, awe-inspiring connection that comes from direct, unmediated experience. There is a profound difference between watching a high-definition video of an ocean wave and feeling the cold spray of the sea on your face. Similarly, there is a unique magic to simply lying on your back on a cool night, away from the glow of screens, and letting your eyes slowly adjust to the true depth of the Milky Way. This direct sensory engagement, the feeling of the vast, silent darkness above, is a deeply human experience that no simulation can fully replicate. The curated, pixel-perfect images on our screens can inadvertently create a sense of detachment, making the cosmos feel like just another form of entertainment, another channel to be consumed rather than a reality to be experienced. The very technology designed to bring us closer to the stars can, paradoxically, insert a new layer of abstraction between us and the genuine article. However, to dismiss these digital tools as merely inferior substitutes would be to overlook their incredible power to illuminate the invisible. The human eye is a remarkable instrument, but it is limited. We see only a narrow slice of the electromagnetic spectrum we call visible light. Virtual astronomy allows us to see the universe in all its multi-wavelength glory. Data visualizations can translate the intense gamma-ray bursts from collapsing stars, the faint infrared heat signatures of stellar nurseries shrouded in dust, or the radio waves pulsing from distant quasars into stunning, false color images that reveal the hidden dynamics of the cosmos. These tools don't just show us more, they show us what is otherwise fundamentally unknowable to our naked senses. They allow us to witness the life cycle of a star, from its birth in a cosmic cloud to its explosive death, compressing millions of years into a few seconds of animation. In this way, digital platforms become not a replacement for direct observation, but a crucial complement, a textbook and a laboratory combined, enabling a deeper, more informed form of wonder. This represents a fascinating new chapter in our cosmic loyalty, one that values global connectivity and data-driven discovery just as highly as solitary contemplation. It is a loyalty that expresses itself in online communities where amateurs and professionals collaborate to classify galaxies from telescope surveys or track potentially hazardous asteroids. It is a loyalty that finds wonder in a raw data set from a space probe, knowing that within those numbers lies the chemical composition of an alien moon's atmosphere. This digital engagement fosters a sense of being part of a global, collective effort to understand the universe, a shared project that transcends borders and backgrounds. It is a powerful 21st century incarnation of the same impulse that led ancient cultures to gather and share stories under the stars. The challenge and the opportunity of our time is to find a conscious balance between these two modes of engagement. We must embrace the power of our technology to educate and connect us, while fiercely protecting the time and space for raw, unscripted encounters with the actual night sky. This might mean using an app to identify a planet and then turning the phone off to simply admire its steady light. It could involve joining a virtual star party to learn about a deep sky object, and then making a plan to travel to a dark sky park to try and glimpse its faint glow for yourself. The goal is a hybrid practice where the knowledge gained from a screen enhances the reverence felt under the open air. By mindfully weaving these digital and analog experiences together, we honor the full spectrum of cosmic connection, from the ancient practice of looking up in wonder to the modern thrill of exploring the universe's deepest secrets through the lens of technology. For far too long, the history of astronomy was written as a story of lone male geniuses, a narrative that conveniently erased half of humanity from the stars. But the truth is, women have always been there, their eyes turned upward, their minds deciphering the celestial patterns essential for survival and spirituality. Their contributions were not the exception. They were the bedrock upon which many ancient astronomical traditions were built, even if their names were lost to time or deliberately omitted from the official record. To rediscover their work is to correct a profound historical injustice and to reclaim a far richer, more complete story of our cosmic journey, one where the sky truly belonged to everyone. Consider the life and tragic death of Hypatia of Alexandria in the 4th century. She was a renowned philosopher, mathematician, and astronomer, a head of the Neoplatonic school who taught publicly and wrote influential commentaries on the complex astronomical works of Ptolemy and Diophantus. In a city famed for its great library, Hypatia was its living embodiment, a brilliant mind who navigated the turbulent politics of her time. Her murder by a Christian mob, fueled by religious and political tensions, was a devastating loss not just for Alexandria but for the entire intellectual world. For centuries, her story was used as a symbolic end of classical learning, but it also stands as a powerful testament to the fact that women could and did operate at the very highest levels of scientific scholarship in the ancient world, their authority and expertise recognized in their own time, even as it was later forgotten. Beyond the Mediterranean, in cultures around the globe, women's astronomical roles were often deeply woven into the fabric of daily life and spiritual practice. In many agricultural societies, women were the primary keepers of the celestial calendar because they were the primary keepers of life itself. Their responsibility for planting, harvesting, and managing food supplies made them the most keen observers of the seasonal cues written in the stars. The rhythm of their lives, knowing when the first spring rains would come, when certain seeds would sprout, when the moon's phase was right for harvesting medicinal herbs, was dictated by the sky. This was a practical, applied astronomy passed down from mother to daughter through oral tradition, song, and the shared experience of tending the land. They didn't need an observatory, their field was their laboratory, and the heavens were their clock. This connection often extended into the sacred realm. In numerous indigenous cultures, female shamans and elders were the custodians of celestial knowledge. They were the ones who interpreted the meaning of a comet's appearance, who led ceremonies aligned with the solstices, and who told the stories of the constellations that held moral lessons for the community. Among the Cherokee, beloved women were revered for their wisdom and often held responsibilities that included understanding celestial cycles. In West Africa, the Dogon people have a sophisticated astronomical tradition surrounding the star Sirius, knowledge that was historically preserved and transmitted by both men and women within their spiritual hierarchy. These women were not mere assistants, they were the authorized interpreters of the cosmos. The bridge between the people and the divine messages they believed were written in the night sky. The systematic overlooking of these contributions is a distortion that modern scholarship is only beginning to rectify. For generations, Western anthropologists and historians, predominantly male, often focused their inquiries on male informants and male-dominated public institutions, missing the vast, vital knowledge held within the domestic and spiritual spheres managed by women. When they did record women's knowledge, it was frequently dismissed as folklore or superstition, rather than being recognized as the valid, empirically based scientific tradition it often was. This bias created a feedback loop that made it seem as if women had no role in astronomy's history, simply because no one had bothered to look for them in the right places or to listen to their descendants. By actively reclaiming these voices, we do more than just add a few names to the historical ledger. We fundamentally transform our understanding of how cosmic knowledge is created and shared. It reveals that astronomy was never a solitary pursuit of genius but a collective human endeavor, a tapestry woven from countless threads of observation and interpretation from every segment of society. This inclusive perspective is not just about the past, It lights a path for the future, honoring the legacy of Hypatia and the countless unnamed female stargazers, inspires a new generation of diverse scientists, showing every young girl who looks up at the stars that she has a rightful place in that grand tradition. It proves that the drive to understand the universe is a universal human trait, one that transcends gender, and that our collective journey to the stars is immeasurably richer when everyone has a seat at the telescope. Now, as we stand on the cusp of becoming a truly spacefaring civilization, our cosmic loyalty faces its most complex test yet. For millennia, our relationship with the heavens was one of observation and interpretation. We looked, we wondered, we told stories. But today, we possess the technology not just to visit other worlds, but to alter them, to extract their resources, and to potentially encounter life utterly unlike our own. This new power forces us to ask a profound ethical question that our ancestors never had to consider. What is our responsibility to the universe beyond our own atmosphere? This isn't just a technical or political challenge. It is a deeply philosophical one, a test of whether our species can mature enough to explore the cosmos not as conquerors, but as conscientious guests. This conversation is already happening under the formal term of planetary protection. Spearheaded by organizations like the Committee on Space Research, these are protocols designed to prevent biological contamination between worlds. When we send a rover to drill into the Martian soil or a lander to the subsurface ocean of Jupiter's moon Europa, we go to extraordinary lengths to sterilize our spacecraft. The goal is twofold: to protect any potential extraterrestrial life we might find from our own earthly microbes, and to protect our own scientific inquiry, ensuring that if we find something, we can be certain it didn't hitchhike from Florida. This isn't just scientific caution. It is a form of interstellar ethics, a recognition that we have a duty of care to preserve the pristine nature of other worlds, to study them without inadvertently destroying what we seek to understand before we even understand it. But the stakes are about to get much higher as we move from exploration to exploitation. The same asteroids that our ancestors saw as divine omens or the wandering souls of gods are now being eyed by corporations and nations for their immense mineral wealth. These floating mountains of iron, nickel, and precious platinum group metals could fuel a new industrial revolution in space, providing the raw materials to build orbiting habitats and fuel depots. The moon's surface holds vast deposits of water ice in its permanently shadowed craters, a resource that could be split into hydrogen and oxygen to make rocket fuel, effectively turning our celestial neighbor into a cosmic gas station. The economic incentive is staggering, but it raises a critical ethical dilemma. Does the principle of finders, keepers apply in the infinite commons of space? Or do these celestial bodies belong to all of humanity, and perhaps to no one at all? This brings us to a fundamental clash of values that echoes the oldest forms of cosmic loyalty. On one side is the perspective of the pioneer, the settler, the entrepreneur, a view that sees the solar system as a new frontier ripe with opportunity, a chance to ensure the survival and prosperity of our species by harnessing the virtually limitless resources beyond Earth. This is a loyalty to human progress and expansion. On the other side is the perspective of the preservationist, the scientist, the philosopher, a view informed by the ancient understanding of the heavens as sacred and worthy of reverence. This perspective asks if we have the right to strip mine an asteroid that has orbited the Sun in peaceful silence for 4 billion years, or to permanently scar the face of the Moon with industrial equipment. It is a loyalty to the intrinsic value of the cosmos itself, independent of its utility to us. Perhaps the wisdom we need to navigate this new frontier can be found by looking back at the oldest stargazers on our own planet. Indigenous cultures worldwide have long held a worldview based on reciprocity and reverence for the natural world, principles that could be extended to our conduct in space. The Navajo concept of Hajo, which encompasses beauty, harmony, balance, and order, could inform a spacefaring ethic that seeks to create harmony with the environments we enter, rather than simply dominating them. The Polynesian voyagers who navigated by the stars did so with a deep sense of kinship with the ocean and the sky, viewing them as partners in their journey, not obstacles to be overcome. What if we approached space exploration with a similar mindset, seeing ourselves not as masters of the universe but as participants within a vast, interconnected system? This dialogue between past wisdom and future challenges is not merely academic, it is urgently practical. The decisions we make in the next few decades, the treaties we sign or fail to sign, the precedents we set for mining rights, the protocols we establish for encountering life, will set the template for humanity's behavior in space for centuries to come. Will we project our old habits of territorial conflict and resource extraction into the stars, or will we learn from our mistakes on Earth and choose a different, more sustainable path? Defining a new cosmic loyalty for the space age means committing to stewardship over exploitation, to reverence over recklessness. It means ensuring that as we reach out to touch other worlds, we do so with a clean hand and a humble heart, honoring the silent, watchful wisdom of the stars that guided our ancestors and now await our next move. There's a quiet, almost primal shift that happens when you step away from the glow of screens and into the embrace of a truly dark night sky. That feeling of your breath catching as you take in the Milky Way's vast, arching river of light isn't just poetic whimsy. It's a measurable, physiological response with profound benefits for our modern minds. Scientific research is now catching up to what our ancestors intuitively knew, that looking up at the stars is a powerful balm for the human psyche. Studies in the field of environmental psychology consistently show that even brief periods of stargazing can significantly lower cortisol levels, the primary hormone associated with stress, while simultaneously boosting feelings of tranquility and well-being. This isn't merely about relaxation. It's about triggering a state of awe, that overwhelming sense of wonder we experience in the face of something vast that transcends our understanding of the world. This awe response is now recognized as a distinct emotional state that can reduce inflammation, increase feelings of social connectedness, and make us more inclined toward generous and empathetic behavior. When we gaze into the cosmic abyss, it turns out we aren't just seeing stars, we're engaging in a form of therapy that is both ancient and urgently relevant. This profound psychological effect likely has deep roots in our evolutionary past. For the vast majority of human history, the night sky was our most constant companion, a source of guidance, wonder, and storytelling. Our brains evolved under this celestial canopy, and a deep-seated familiarity with it may be woven into our very neurology. The act of looking up and seeing a predictable, orderly, and beautiful universe above the chaos of daily life provides a powerful cognitive anchor. It offers a perspective that psychologists call the overview effect without ever leaving the ground. A gentle reminder that our personal anxieties and daily struggles are part of a much larger, more magnificent picture. This shift in perspective from the micro to the macro can instantly diminish the weight of our problems, not by solving them, but by contextualizing them within a cosmos of unimaginable scale and age. This isn't about escapism, it's about recalibration. It fulfills a fundamental human need for grandeur and meaning, a need that is often starved in our curated, algorithm-driven digital lives where our focus is constantly pulled inward to our own small world. In our contemporary, technology-saturated existence, This practice takes on a new role as a vital form of digital detox and mental hygiene. The constant barrage of notifications, the endless scroll of social media, and the blue light of our devices keep our nervous systems in a perpetual state of high alert, a condition sometimes called continuous partial attention. Stepping outside to look at the stars is the antithesis of this. It demands our full and undivided focus, but in a way that is gentle and effortless. It is a form of mindfulness that doesn't require any special app or guided meditation, just a willingness to be present and to look up. The night sky doesn't demand anything from us. It doesn't sell us anything or ask for a like or a share. It simply exists, offering a silent, majestic spectacle that encourages quiet contemplation. This break from the frenetic pace of modern life allows our overstimulated brains to downshift, to enter a more restorative state where creativity can flourish and mental clutter can settle. It's a chance to disconnect from the Wi-Fi and reconnect with something infinitely older and wiser. Cultivating this personal cosmic loyalty, this regular habit of seeking out the stars, becomes a powerful tool for enhancing overall well-being. It's about intentionally carving out moments for awe in our weekly routines, whether that's a nightly few minutes in the backyard after turning off the lights or a monthly trip to a local park to watch the moonrise. This practice builds a personal relationship with the cosmos that is entirely your own, one that is separate from scientific facts or ancient myths, though it can be enriched by both. You might start to recognize the steady journey of Jupiter across the seasons or anticipate the return of your favorite winter constellation. This familiarity breeds not just knowledge, but a deep, comforting sense of place within the universe. It transforms the sky from a distant abstraction into a meaningful part of your personal landscape, a constant in a world of change. In doing so, stargazing becomes more than a hobby. It becomes a ritual, a way to find balance, cultivate peace, and remember that we are, and always have been, citizens of a spectacular and star-filled universe. As the tools of modern astronomy reach every corner of the globe, a new and deeply important conversation is emerging, one that challenges us to consider not just what we learn about the universe, but how we learn it and from whom. The incredible wealth of indigenous astronomical knowledge, honed over tens of thousands of years, represents a vast and largely untapped library of human understanding. Yet, as Western science seeks to explore and incorporate these different ways of knowing, it often stumbles into the trap of cultural appropriation, the act of taking elements from a marginalized culture without permission, context, or respect. This isn't about refusing to share knowledge. It's about the critical difference between sharing and taking, between collaboration and extraction. When a researcher or documentarian presents an Aboriginal story about the emu in the sky as a charming myth without engaging the community it comes from, they reduce a complex system of ecological law and spiritual belief to a simple parable, stripping it of its depth and its living connection to a people. This act, however unintentional, disrespects the cultural heritage and the sovereign intellectual property of the First Nations peoples who have safeguarded this knowledge through generations of persecution and forced assimilation. Ethical engagement demands a fundamental shift in approach, moving from a model of extraction to one of partnership and reciprocity. It begins with the understanding that indigenous astronomical knowledge is not a free-for-all resource waiting to be discovered by outside academics, but a deeply embedded part of a living culture. The proper protocol is to first seek permission, to approach knowledge keepers and community elders with humility and a genuine desire to learn, not just to acquire data. This means acknowledging that these star stories are not in the public domain. They are owned by the communities that created them. Collaboration is key. This means working with indigenous partners from the very inception of a project, ensuring they have agency in how their knowledge is used, represented, and shared. It means compensating them fairly for their time and expertise, and most importantly, ensuring the benefits of the collaboration flow back to the community, whether through co-authorship on papers, shared revenue from publications, or support for local educational initiatives. This process acknowledges that different knowledge systems have equal value, not that one is superior and the other is merely a source of interesting data to be validated or discarded by Western science. This commitment to cultural sensitivity is the new frontier of cosmic loyalty. It recognizes that our reverence for the sky is incomplete if it doesn't extend to a reverence for the diverse human cultures that have interpreted it. A truly inclusive astronomy doesn't just point telescopes at the stars, it also listens to the voices of all the people who have looked up in wonder throughout history. It creates space for indigenous astronomers to share their perspectives within scientific institutions and for their knowledge to be taught alongside Kepler's laws and Newton's theories, not as a footnote, but as a parallel and equally valid way of understanding the cosmos. By actively working to honor these traditions rather than erase them, we do more than avoid harm. We actively enrich our collective understanding. The Navajo concept of Hojo, which encompasses beauty, harmony, and balance, can offer a vital ethical framework for our own efforts in space exploration and environmental stewardship. The Polynesian art of wayfinding, a sophisticated science of navigation, can teach us about resilience and deep environmental connection. Learning from past mistakes and embracing this collaborative model fosters a much richer, more vibrant global astronomical community. It allows us to see the same patch of sky through multiple lenses, each revealing a different layer of truth and meaning. When we approach indigenous knowledge with respect and partnership, we aren't just being politically correct, we are being better scientists and more enlightened humans. We open ourselves up to a universe of wisdom that has been written in the stars for millennia, waiting for us to finally learn how to read it with the right kind of loyalty, a loyalty that embraces not only the cosmos above, but also the diverse tapestry of human experience here on Earth. We are living through a golden age of cosmic revelation, a time when the veil over the universe's deepest secrets is being pulled back by engineering marvels like the James Webb Space Telescope. This incredible instrument peers not just across space, but across time itself, capturing the faint infrared glow of the very first galaxies to ignite after the Big Bang. It analyzes the atmospheres of distant exoplanets, searching for the chemical fingerprints that might hint at the presence of life. The data it returns is a torrent of pure, unassailable fact, a map of the physical universe of unprecedented detail and scope. This represents the pinnacle of one way of knowing, the empirical, the measurable, the objective. It is a triumph of the human intellect, a testament to our relentless drive to understand the mechanics of existence through observation and reason. Yet, in a fascinating and perhaps necessary counterbalance, there is a powerful cultural undercurrent pulling us in a different direction. At the very moment we can see the cosmic dawn, there is a growing collective desire to reconnect with the oldest ways our species has understood the heavens. This isn't a rejection of science, but a search for something it cannot provide on its own, meaning. People are looking to the Maya concept of cyclical time, not to predict apocalypses, but to find a model for sustainability that breaks from our linear growth at all costs mindset. Engineers and ecologists are studying Polynesian wayfinding, not to navigate with stars, but to learn a philosophy of profound environmental attunement, where the navigator is in a constant, respectful dialogue with the ocean, wind, and sky. This movement seeks to reclaim the narrative, spiritual, and ethical dimensions of the cosmos that were central to ancient interpretations, but often sidelined in modern astronomy. The most exciting possibility for our future is not a choice between these two paths, but a conscious and respectful synthesis of them. Imagine a form of cosmic loyalty that holds both the data from a space telescope and the wisdom of a star story in equal regard. This holistic view would serve both our intellect and our spirit, for the immense challenges ahead, like navigating the ethical minefield of space colonization or reversing the damage of climate change. We will need more than just technological solutions. We will need a guiding ethos, a moral compass. The indigenous principle of considering the impact of every decision on the next 7 generations is a stellar navigation chart for sustainability, a concept far more profound than any corporate mission statement. The ancient view of the Earth as a single, living organism, a perspective echoed in the overview effect described by astronauts, could be the foundational ethic that prevents us from treating other planets as mere resources to be plundered. This fusion promises to make the next era of astronomy the most inclusive and insightful in human history. It creates a bigger table, inviting not only astrophysicists and engineers to the conversation, but also poets, artists, philosophers, and indigenous knowledge keepers. In this collaborative model, the launch of a new probe to Jupiter's moon, Europa, would be celebrated alongside the revival of a nearly lost celestial navigation tradition in the Pacific. A scientific paper on dark matter would be discussed in tandem with an Aboriginal dreaming story about the emu in the sky, each recognized as a different but equally valuable way of engaging with the mystery of the universe. This approach doesn't dilute science. It enriches our culture by framing our incredible empirical discoveries within a much older, deeper human conversation about who we are and what our role is in this vast, astonishing cosmos. The future belongs to those who can look through a telescope with one eye and listen to the ancient stories with the other, weaving a new understanding that is both brilliantly enlightened and deeply humane. Imagine a classroom not with rows of desks facing a whiteboard, but with students gathered around a simple, homemade sundial they've just constructed from cardboard and a stick. They're not just learning about angles and shadows, they're actively waiting, watching as the slow-moving finger of shadow tells them the hour, just as it did for a Babylonian timekeeper or a Roman farmer. This is the powerful shift happening in education today, as teachers from elementary schools to universities are weaving the rich tapestry of ancient astronomy into their curricula. It's a move that transforms abstract science into a tangible human story, connecting the dots between the laws of physics and the cultures that first discovered them by simply looking up. This hands-on, interdisciplinary approach is revolutionizing how we teach. Instead of presenting science, history, and art as separate subjects, educators are blending them into a single, captivating narrative. A lesson on the Maya isn't just about reading their history, it's about calculating their long-count calendar or building a model of El Castillo to see the serpent of light slither down its steps at the equinox. A unit on navigation doesn't stop with a textbook diagram of celestial coordinates. It challenges students to find north using the stars, just like a Polynesian voyager, or to plot a course using only the sun. This method does more than just make learning fun. It demonstrates that true understanding rarely fits into neat, separate boxes. It shows students that the greatest discoveries often happen at the intersections, where math meets mythology, where engineering meets ecology, and where careful observation meets creative storytelling. Perhaps the most vital aspect of this educational renaissance is the long overdue recognition and integration of indigenous knowledge systems. For far too long, standard textbooks presented a narrow, Eurocentric view of scientific progress, often relegating the astronomical achievements of Native American, Aboriginal Australian, or African cultures to the realm of folklore or superstition. Today, forward-thinking educators are correcting that record. Students might study the Navajo constellation of the whirling male twins, known as N-A-A-Y-E-acute ejectives, and learn how these heroes represent principles of harmony and balance central to the Navajo worldview. They might explore how the aboriginal emu in the sky is not just a pattern of dark nebulae, but a detailed ecological calendar signaling the right time to gather eggs. This isn't about replacing Western science, it's about enriching it, showing that there are multiple, valid ways of knowing the world. It teaches respect for other cultures not as a sidebar to history, but as a core part of our collective human heritage, fostering a generation that values diversity of thought and perspective. Ultimately, this approach is about helping young people forge their own personal connection to the cosmos, their own unique form of cosmic loyalty. For some, that might mean a passion for astrophysics, ignited by understanding the precise geometry behind an ancient observatory. For others, it might be a deeper appreciation for their own cultural ancestry, discovering the star stories their great-grandparents might have known. For many, it might simply be the gift of awe, the ability to look up at a starry night and see more than just random points of light, but a library of human history, a map of scientific discovery, and an invitation to wonder. By giving students the tools to interpret the sky through both a scientific and a cultural lens, we empower them not just to be passive consumers of information, but active participants in the oldest human tradition of all. We ensure that the wisdom of the past doesn't gather dust in a museum but lives on, informing the innovators, explorers, and storytellers of tomorrow, who will undoubtedly add their own brilliant chapters to our ever-evolving relationship with the stars. Developing a personal connection to the cosmos doesn't require a fancy telescope or a degree in astrophysics. It begins with the simple, profound act of looking up with intentional curiosity. Start by getting to know the constellations that are native to your slice of the sky. In the Northern Hemisphere, you might begin with the unmistakable Big Dipper, using its pointer stars to arc to Arcturus and speed on to Spica. Those in the south can anchor their view on the Southern Cross, a compact but brilliant guidepost. While modern tools are incredibly helpful, try not to become overly reliant on your smartphone app. Use it to identify a pattern, then turn it off and let your eyes adjust to the darkness, allowing yourself the satisfaction of finding that same pattern again unaided. This process of learning to navigate the celestial sphere is the same foundational skill practiced by every ancient culture. It's how you move from seeing random dots of light to recognizing a familiar map, transforming the sky from a stranger into an old friend. To truly appreciate the majesty our ancestors knew, you must make a pilgrimage to experience a genuinely dark sky. The growing global movement of dark sky preserves and parks offers sanctuaries where artificial light is minimized, allowing the full glory of the Milky Way to reveal itself as a shimmering, arching river of stars. Planning a trip to one of these locations is more than a vacation. It's a spiritual retreat. Even more accessible are local star parties, often hosted by astronomy clubs or universities. These gatherings are wonderfully welcoming events where seasoned astronomers happily share their powerful telescopes, offering you breathtaking close-up views of Saturn's rings, Jupiter's storm bands, or the ghostly glow of a distant nebula. Standing in a line of strangers, all waiting for their turn at the eyepiece and gasping in shared awe at the same sight, fosters a powerful sense of community, a reminder that wonder is a universal language that connects us all under the same cosmic roof. To deepen this practice from a casual hobby into a meaningful ritual, consider keeping an astronomical journal. This isn't just a log of what you saw, it's a record of your relationship with the sky over time. Note the date, time, and conditions, but also jot down your personal reflections. When did you first notice Orion returning to the pre-dawn sky, heralding the coming of winter? When did the summer triangle shift from directly overhead to the western horizon, signaling the transition to autumn? Over a year, this journal becomes a deeply personal almanac, attuning you to the slow, grand dance of the seasons as told by the stars. It grounds you in cyclical time, counteracting the frantic, linear pace of modern life and providing a constant, calming reminder of the larger, more enduring rhythms that govern our world. Perhaps the most enriching way to forge this bond is to explore the celestial stories of the land you inhabit. If you live in North America, research the astronomical traditions of the indigenous peoples native to your region. You might discover that the Lakota people see the Big Dipper not as a bear or a wagon, but as a great racetrack where 7 spirits run forever across the sky. In Australia, you could learn how the Aboriginal stories of the emu in the sky, a shape defined by the dark dust lanes of the Milky Way, dictate the timing for gathering eggs. If your own ancestry lies across an ocean, delve into the star lore of your forebears. Perhaps your ancestors were Vikings who navigated by the North Star, or Polynesians who memorized the rising points of hundreds of stars for open ocean voyages. This research does more than just provide interesting facts. It layers the sky with meaning and memory, connecting your personal gaze to a timeless human conversation across generations. You are not just looking at stars, you are participating in a heritage of wonder, adding your own chapter to an ancient story that began when the first human looked up and felt the irresistible pull of the infinite. But this creeping blanket of light does far more than just rob us of a beautiful view. It severs a fundamental connection to the natural rhythms that have guided life on Earth for millennia. For countless species, the artificial glow of night is a profoundly disruptive force, a false signal that throws their entire biology into chaos. Sea turtle hatchlings, instinctively programmed to scramble toward the moonlit ocean, become disoriented by beachfront streetlights and wander inland to their deaths. Millions of migratory birds who navigate by the stars on their epic seasonal journeys are drawn off course by the luminous vortex of a city, circling endlessly until they collapse from exhaustion. The intricate dance of predator and prey is thrown out of balance as darkness no longer provides cover for the hunted, and the feeding patterns of nocturnal insects like moths are catastrophically altered, with devastating consequences for pollination. Even our own human health is not immune. The constant nighttime exposure to artificial light, particularly the blue-rich glow from LEDs and screens, suppresses the production of melatonin, a hormone critical for regulating our sleep-wake cycles. This disruption is linked to an increased risk of sleep disorders, depression, obesity, and even certain cancers. Light pollution, in essence, is a form of ecological vandalism, breaking the ancient contract between the earth and the sky that every living creature depends upon for its well-being. Thankfully, a growing global movement is pushing back against this luminous tide, advocating for a more thoughtful and intentional relationship with the night. Organizations like the International Dark Sky Association are at the forefront, working with communities, manufacturers, and policymakers to promote responsible outdoor lighting. Their mission isn't to plunge our cities into darkness for the sake of astronomy, but to champion the simple principles of good lighting, using shields to direct light downward where it is needed, choosing warmer-colored bulbs with less biologically disruptive blue light, and installing timers and motion sensors to ensure lights are only on when necessary. Their efforts have led to the certification of over 200 international dark sky places around the world, parks, communities, and reserves that have made a committed effort to protect their starry nights. These places are becoming modern-day pilgrimage sites, offering a glimpse of a heritage that most of the world has lost. Annual events like International Dark Sky Week and Globe at Night invite everyone to participate in simple activities, from turning off unnecessary outdoor lights to counting stars in a specific constellation to contribute to a global map of light pollution. These actions empower individuals, giving them a tangible way to become part of the solution and reclaim their own small piece of the night. Choosing to support this cause is one of the most direct and powerful ways we can honor the cosmic loyalty of our ancestors. They lived in a world where the stars were an intimate and indispensable part of daily life, a source of guidance, timekeeping, and profound spiritual meaning. By taking steps to preserve the darkness they cherished, we are effectively safeguarding that legacy for the generations who will follow us. It is a promise that a child born in the future will still have the opportunity to lie on their back and feel the dizzying awe of the Milky Way stretching from one horizon to the other, to understand the true meaning of infinite space, and to feel that personal, humbling connection to the universe. This isn't just about nostalgia. It is about fulfilling a duty of stewardship for a shared human experience that is as vital and enriching as protecting a great forest or a clean river. The night sky is the largest and most ancient world heritage site we have, and it belongs to every single person on the planet. By fighting for its preservation, we are not only reconnecting with the natural world and the cosmos beyond, but we are also affirming our commitment to a future where wonder and perspective are not extinguished, but are allowed to shine on as brilliantly and enduringly as the stars themselves. Our journey through the cosmic loyalties of our ancestors reveals something far more profound than a simple historical curiosity. It uncovers a universal human impulse, a deep-seated need to find our place within the vast, silent expanse of the universe. From the very beginning, we have looked up and seen more than just points of light. We saw a divine clockwork governing the seasons, a celestial roadmap guiding our voyages, and a grand storybook where our myths and heroes were immortalized alongside the gods. The night sky was our first library, our first temple, and our first compass, offering practical navigation for the body and profound spiritual guidance for the soul. It served as a canvas for our deepest questions about life, death, and creation, a mirror reflecting our greatest fears and our most aspirational hopes back down upon us. While the tools of modern science have expanded our knowledge to almost unimaginable depths, revealing the nuclear furnaces within stars and the gravitational waves from colliding black holes, this flood of data has not diminished our innate need for wonder. If anything, it has magnified it. Knowing the precise chemical composition of a nebula or the exact distance to a galaxy does not strip away its mystery. It adds layers of breathtaking complexity to it. We now understand that we are physically woven into this cosmic tapestry, that the atoms in our bodies were forged in the hearts of long-dead stars. This scientific revelation is the most powerful creation story ever told, one that connects us to the cosmos not just spiritually but physically. Our curiosity has been rewarded with a humility far greater than any imposed by ancient myth, a humility born from truly comprehending our tiny, yet significant, place in an ever-expanding universe. When we tilt our heads back to gaze at the stars tonight, we are not alone in that act. We are standing on the shoulders of countless generations who also looked up and sought connection. We are joining the Babylonian scribe meticulously recording the path of Jupiter on a clay tablet, the Polynesian navigator chanting the rising stars for an ocean voyage, the Maya day keeper calculating a sacred calendar, and the indigenous storyteller pointing out the emu in the dark spaces of the Milky Way. We are part of an unbroken chain of wonder that stretches back to the very first human who felt a sense of awe under a sky unpolluted by light. Their legacy is not just in the stone circles they built or the stories they told, but in the very act of looking up and asking why. Carrying their wisdom forward does not mean abandoning our telescopes for astrolabes. It means blending the best of both worlds. It means pairing the precision of our science with the poetry of their interpretations, allowing empirical discovery to coexist with spiritual reverence. The future of cosmic loyalty lies in this beautiful synthesis, a commitment to curiosity that drives us to explore further, a practice of respect for the cosmos and for the diverse ways humans have known it, and a cultivation of pure, unadulterated awe that remains our truest response to the universe. This balanced path encourages us to be both explorers and stewards, to reach for other worlds while protecting the preciousness of our own, and to listen for extraterrestrial signals while preserving the ancient star stories right here on Earth. So tonight, or any night you can, make a point to step outside. Find a patch of darkness, let your eyes adjust, and simply look up. You don't need to know all the constellations or the science behind every twinkling light. Just breathe in the same spectacle that has captivated humanity since the dawn of time. See the same stars that guided travelers across trackless deserts and uncharted oceans. In that moment of quiet connection, you will feel it, the gentle pull of an eternal story, a narrative of curiosity and wonder that you are now a part of. You are the latest witness in a lineage of stargazers, and the cosmos awaits your continued chapter.